Okay, so let's start with the beginning, of course, and I'm going to go through the official content. In other words, I'm looking at the official content of the training, and I will not share this with you guys, and you guys know why for sure, because it will be just unethical and completely illegal. However, I can verbalize what's here. So chapter 1 starts with getting started with Red Hat Enterprise Linux, and it starts with a question that is, what is Linux? Okay, so this is kind of the RH124. It's not the first, but officially it's the first training course when you get in on the Red Hat ecosystem, right? So it makes quite some sense for this to be the first question or the first thing they approach on the course. So I won't be too detailed about this because if you guys are leading here in this training series in this playlist, it's because you guys most likely already know what Linux is and what Red Hat is. But it basically shows you what Linux is. It talks to you about that it's a very widespread operating system with many people adopting Linux, not only Red Hat but many other Linux versions, many other Linux distributions. They kind of show why Linux is great. It's open source, it's command line based, it's modular, it's very effective, and why they talk about why open source. So all of this stuff, you I'm sure you guys can get this information from other sources. And this is kind of, they start this just to kind of to establish or give motivation to the student to sit down and learn about an open source, quote unquote, open source Linux operating system. Then they go about talking about what is a distribution. I can share with you guys some information. Let me just show you. Give me a second. I have a browser ready for this, but I closed it by accident. So just give me a second. Well, we're going to explore. We're going to explore a site that is called DistroWatch. Let me just swap this so you guys can see. Okay, there you go. So we're going to explore a site called DistroWatch. I don't endorse this site. I'm not sponsored by this site by any reason. It's just a good place to get a list of. I'm not sure if there are all Linux distributions, but at least most Linux distributions. So you go here to the right hand side and say page sheet ranking. You guys can see my mouse over there. It's there. So here you can see, or they have a kind of a ranking. I'm not going to say that this ranking it's very accurate or not accurate at all. It's just a ranking like any other ranking that you can use as a reference. If you have the websites that you prefer as a reference, you can just use them. It's fine. It's just a list of possible Linux distributions. So basically, a distribution is, in a very simple terms, it's a group of the Linux kernel that can be obtained freely. So if you go to a site called kernel.org, you can obtain the kernel freely. You can just download it and it's yours. So distribution, it's a kernel or the kernel like it is or tailored to your liking, and a group of applications. So this is going to spawn a Linux distribution. So the kernel plus the applications will just create a distribution, which is a Linux, a different version or different philosophy of Linux, depending on the actual use case for each Linux. In my opinion, there are no better or worse Linuxes. All of them have the pluses and their minuses. It's most of the time a matter of personal preference, and since they are mostly free, you can just download as many Linuxes that you want to use and just enjoy the one you prefer. If you don't like the one you downloaded, just try another one until you find one that you actually like. So that's just my opinion. Put down in the comments below if you do not agree with me, but that's just my opinion. So we have here ranking, MX Linux, Mint, Endeavor, blah blah blah, all of these. And if you look for Red Hat, I don't know if I'm going to be able to find it with my own eyes because I have that problem. Oh, there it is. So Red Hat, it's on ranking 69. Nice. Just a coincidence. I didn't know. So Red Hat is kind of lower on the list just because Red Hat it's a kind of an enterprise Linux, so it's not free per se. You can download and install Red Hat for free, yes, but in order to get support and most of the updates, you need to pay for a license. There are very cheap licenses, that's true, but you have to pay for it. While most of the others are just free to obtain, free to update, and free to use. I'm not going to use Red Hat here in this training or my exercises. I'm going to use Rocky Linux. Rocky Linux is just a kind of a clone of Red Hat. It's the same thing. You can they basically they are the same thing. Okay, there is no difference. But Rocky Linux it's free to use and free to use. And I have access to all the updates and all of that good stuff for free. So and I'm just using free software. So that's basically that. But it's the same thing. What we are going to do here this week or this month, whatever, how much time it takes me to do this series, it's going to be on Rocky Linux, which is the same thing as well. So you can reference yourselves. You can reference yourself to this website to see what are the offers of Linux distributions. You can pick the one, or if you want to stick with the one I'm going to use, it's Rocky Linux. You can download it freely. It's free to use. It's all good. So basically, distribution it's the kernel, the Linux kernel plus the applications that will create a Linux with a specific use case. Or there are more generic Linuxes. There are more specific use case Linuxes. You can just go through the DistroWatch. DistroWatch is just one site that I'm using. I don't have any special care or special love for this site. It's just it's the site I use for the longest time, and I just go there because it works. Then continuing with all the chapter 1 stuff, then they go why Red Hat. So who is Red Hat? Why Red Hat? Blah blah blah. Well, basically you kind of adopt Red Hat because it's a enterprise-centered operating system, and it has official support and official updates. So most of the other Linuxes on DistroWatch they have support and updates, yes. But it's kind of there are obviously can be exceptions, but for the most part, you get free updates and free free support from the community. So it's kind of everybody helping each other. With Red Hat, you have official support, official training, and official updates. It requires a fee, you have to pay, but at least it's there. And if you are running a big enterprise, you want to have that kind of that reassurance of having support when you need it and having people help you when you actually need that help. So that basically covers the first chapter. It's kind of a pat in the back for RHEL, saying that it's true that it's a very reliable and you have official support for that operating system. Again, and they also mentioned that you can go to the Red Hat's website and obtain a free copy of RHEL. That's true. They have different versions that can obtain for free, but at a certain point, you have to pay for a fee to have all the full updates and full support. They also mentioned containers, OpenShift, that are products that are kind of parallel or in series, depending on your approach, of the main RHEL-based operating system. So you have RHEL, that is your base operating system. RHEL, when I say RHEL, it's Red Hat Enterprise Linux. So you have RHEL, that is your base operating system. Okay, you have your base operating system. Then you have products that are built upon it. Most noticeable mentions can be said as Ansible, OpenShift, running containers, and also Red Hat virtualization. But that's for another time. All of this is about the base operating system. We have lots to do and lots to work, and we're going to start this right now. Like and subscribe if it really helps, and it will keep you up to date for my future videos of all 12 or 13 or 15 videos about this series. And I'll see you in the next one, guys. Cheers. All right, so chapter 2, it's all about accessing the command line. So it's actually the name of the chapter, which is access the command line. Yeah, they go straight to the point because they know that Linux, it's basically a command line based operating system, right? So even though we do have the graphical interface, which I'm going to show you right now, we will not use the graphical interface per se that much. So basically, throughout this video series, the graphical interface is going to be a way to access the command line, because that's where we're going to live most of the time. We're going to revisit the graphical interface more till the end of the video series, okay? But for the most part, we're going to be using the command line. And right now, you're going to see, I'm going to use the graphical interface just to show you how we can get to the command line through the graphical interface. But for the remainder of this video series, I am not going to use the graphical interface all that much, only if I need the browser or stuff that, I mean, it's much easier to show using the graphical interface, okay? So if I go here, you guys can see the graphical login screen of one of my example systems. So this is Oracle Linux, like I told you before. If this was a Red Hat system, it will be very similar. Okay, it will be just how do you call it, cosmetically different, but technically the same. Okay, so you are not. I will. If you guys want me to, I'm not sure if I'll do this video or not. I'm debating. But if you want me to do a video specifically how to install a Rocky Linux VM, let me know in the comments below, and I will happy to do a separate video all about that. So when I installed this Rocky Linux VM, I created an add-on user called student. It could be called anything, but I call him student. So that's what is popping here. So I'm going to click on the student user. I'm going to type his password. And I'm going to log in to the graphical interface. So that's quite simple to do. If you have experience with any other operating systems, it's the same thing. So it's the same thing. You cannot see it because I have to resize this. But on the top left, you see menu called activities. You can click it, and it's going to show you this bar below. You are not losing much. But I have to resize this. I can see it. I'll do it for the next video. You're not going to lose much. You just click activities and you will see that there's a menu here and a search bar on the top. And I can try and let me see if I can do it like this, and maybe you can see it like this until I fix this in a more permanent fashion. Yeah, this works. Okay. So I can put it something around here, look pretty. Cool. Now you have here the activities menu. Okay, you have it here, and it's going to show you the search bar. Okay, and below you have this how do you call it, these icons. One of the icons is terminal, and that's how you access the command line. Okay, so that's basically it. You have access to the command line. I will not use this command line not all that often. I'm going to use a different method to get to these machines because it's easier for me. But if you are using a graphical interface, you just click the activities. You see this thing pop up in the bottom. You click terminal, and you are basically good to go. So as you can see, the lettering is very small. So if you do Control+ on a keyboard, you can increase the font size. Control+, and you can just make this a little bit easier to read. Okay, I'm not going to use this all that much. I'm going to use a different method using these terminals here. Okay, because it's easier for me to do so. Okay, it's much easier for me to use this this approach. It's much more manageable to me, but that's just me. But if you want to access, you click activities on the top left, and you hit terminal, and you have your terminal, and you are good to go. I'll come back here. Well, since I'm here, I can use it. So as you can see here, you can get lots of information just by opening a terminal. You can see here what is your username, and this is the @ symbol. It's just the @ symbol, nothing special. Then you can see your machine name, your server name. And this is about something I'm going to discuss on chapter 3, which is kind of the file system location where you are at right now. The tilde means something special, but I'll get into it later. And the $ means that you are right now a regular user. You probably see the $ and the hashtag sign more often. So hashtag sign means you are the root user, and usually the $ means you are just a non-root user. In other words, a regular user. Okay. So this is a graphical. It's a server with a graphical interface installed. If you have one server or any server that does not have the graphical interface installed, then you see something like this. You just log in as usual. I just mistyped the password because that's me doing fat fingers. And you log in as usual. You'll see the same information. Here I am not able to increase the text size, but you guys kind of see it. So as you can see, I have here the same, basically the same thing. Okay, the $, the student at Rocky 2, which is my secondary machine, and the tilde, which has special meaning. It's the same thing, only not using the graphical interface with the machine without any graphical interface installed, which is most likely the most common use case you will find. It is a machine without the graphical interface installed. Okay. Either way, is the functionalities of the graphical terminal or the more pure terminal in a way, they are the same. What you can do with the one, you can do with the other. It's just fine. The graphical interface has the option, has the advantage of, I mean, you can choose your fonts, you can increase the font size, you can create secondary windows. So, like you can imagine, graphical interface has some comfort advantages. But in terms of functionality, it's the same thing. What you do here is what you do there. They are basically the same thing. Okay, no difference there. It's just a matter of interfacing with the terminal. If you are happy using this method, be my guest. If you prefer this method, be my guest. It's the same thing. Some purists say that this is better. Some people more relaxed like me say this is the same thing, and I do tend to agree. So, as you can experience throughout this video series, you can just pick the one you prefer and you are good to go. It's basically the same thing. Okay. As the video series progresses, I'm going to show you how to install a graphical interface on a server that does not have the graphical interface installed yet. In this case, my Rocky 1 machine has the graphical interface installed from scratch, so it's already ready to go. Again, you can use this one or that one. It's the same thing. So, however, if you are using like this without a graphical interface, so if you are using graphical interface, you have this option of multiple windows, which is nice. But you have something similar here too. So if you are using something that is purely text, you can do a keyboard combination of doing Control, Alt, and for example, F2 or F3. And as you can see, when I hit F3, I have access to another terminal. Okay. So this is going to depend on your Linux distribution, versions, how old the Linux is. But you have access to multiple. So I have the F1, F2, F3, the F4, F5, and F6 should be another one. Yeah. F7 should be not there. So F1, F2, F3, F4, F5, F6, F7, F6. Okay, so can Control Alt F1, which is TTY0, Control Alt F2. I'm not, F1 is F1, F2 is TTY2, F3 TTY blah, 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 blah. Never mind. Control F1, Control F2, Control F3, Control F4, Control F5, Control F6. So in this machine, I can go do Control Alt F1 till 26, and I have 6 different terminals to work with, and each one is doing its own thing. I have something, the same thing happens with a server installed with graphical interface installed. It's the same thing with slight differences. So if I do Control F1, I get this is kind of reserved for the graphical interface. And there we go. Control F2, Control F3, Control F4. It's slightly different. You can experiment because it's going to depend and vary a little bit depending on the Linux you are using, depending on the distribution you are using, depending of the graphical interface you have installed. But now that I speak of it, the graphical interface you are using here, it's GNOME. What is a graphical interface? It's kind of the Windows decorations. It's, in my opinion, it's just that. It's just decoration. It's just look and feel. It's just the feel and the look of the graphical interface. You have GNOME, you have KDE, you have CXFCE, you have Window Maker, you have these dozens of different graphical interfaces or different environments you can use. In my opinion, it's just a matter of personal preference. Since GNOME is pre-installed with Rocky and GNOME is also pre-installed with RHEL, I just stick with those because it's already there. I don't have to install it myself. It just works. And since if you are using RHEL, most likely you are creating an enterprise server. So you won't be using the graphical interface all that much. It's just something you can use to fall back into in case of anything that graphical interface will make your life easier, right? So GNOME will work. GNOME works for me, and I have no issues with GNOME. So I just use GNOME for the most part. But again, it's personal preference. Put down in comments below which one you prefer. If you agree or if you disagree for me, it's fine. You can just say your own opinions, and everybody's entitled to it. Okay. Once you have access to the graphical to the command line, I will stick with this for now, but I will use a bigger font. Since I'm already here, I'll just stick with this. I don't see why not. Let's just wrap this chapter up with some common used command line utilities. Okay. I will not go through every single command line utility that any Linux or RHEL has available, because that will just be completely dumb, because it's just an infinite list between built-in tools and other tools you can install from third parties and yourself. But you can go through a small toolkit of most common tools you would use on an enterprise server like RHEL. Without any special order, this is not personal preference. This is just how they order this on the official content. Let's just go through a few most commonly used tools. Nothing special, just to get your juices flowing and your motivation going. And of course, throughout the video series, we will just add more and more on top of this. Okay. So, for example, they start with the Who Am I tool. Okay, the Who Am I, it's part of a series of tools that say similar things. So Who Am I, the tool itself kind of tells everything. So Who Am I tells me who am I. So I am the student user on currently, because now it's quite obvious that I'm the student user. It's quite obvious, but in some situations it's kind of it gets a little bit confusing to know who you are since the Who Am I. Okay. So Who Am I will tell you that. There are other tools, for example, the ID command also tells you that with the different detail. Again, if I show you multiple tools, I'm not telling you which one is the best, is the best, or it's better than the other, because that's just stupid. All of them have a purpose and a time to be used. Put on the comments below if you do disagree. But there are many tools with similar purposes, and just pick the ones you remember or the ones you want to use. I mean, who we are to say which one is better. Okay, based on preference, based on the one I remember at that time, just use the one you like the most. Going back to the Who Am I, all of these tools are running on a terminal, yes, but the terminal has a shell. So I'm going to make some comments, and to do a comment, I'm going to use the hashtag. This is going to be something, not a command. Okay, so this is going to be something like, okay, this is going, if I put an hashtag, the terminal is going to ignore. It's like a commentary. So below this terminal, so this is the terminal tool from GNOME, right? So, but below this terminal tool, there is a thing called the shell, and the shell, what the shell does is going to convert text strings into kernel commands. So if I type Who Am I, it's just a text string, but this is going to convert this text string into something that the kernel can understand. That's what the shell does. And at this point, we are using the bash shell. Okay, so the ps command is called process tree. We'll discuss this a little bit in more detail later. But the process tree is kind of the Windows Task Manager, but in text mode. So the bash is going to be our shell, and this is the shell that is going to read these commands and convert them into something that the kernel can understand and actually execute with some order or some type of result for us. Okay. So if there are many shells, you have the not that many, but different shells. Have shell, you have the shell, TC shell, and others. But in Linux, we use by default the bash, which is the burn again shell, and that's the one we use by default. Again, no special reason to change unless you have some specific motivation to do so. So we'll just stick with the bash for now, which is perfectly fine. If I had not mentioned this to you guys in this video, you probably will not even know that this exists, and this will create no actual stress to you. It just works. Okay. At this point, you don't have to worry too much about this. However, if you are doing tasks that requires the bash, like some type of scripts or automation, some scripts are built for bash. So if you use a different shell, maybe the script will not work. But that's a different story. Bash will work for you, and that's what you're going to get. Okay. So, for example, if I do the who am I, again, I can do minus help. This is going to give me a help of this command. This will apply to 99% of the commands. For example, ID minus help. Some commands do not support this, but that's again something to be discussed later on. Most of the commands will support this. Okay, so you do the command minus help, and this I'm going to put this over my head. And this is going to show you some help about the command itself. There are other ways to obtain help. We'll discuss this later on, yes. But this is the one I'm going to use for now. So who am I will show you who you are. That's not too complicated. If you want to run commands in sequence, for example, who am I followed by the ID command, you can do the column. Okay, this is going to, the semicolon, and this is going to run commands in sequence. Other commands that are on my list, you can use the date command to show you what time is it, and set the time. However, the date command is kind of has a easier command to use, at least in my opinion, which is time date CTL. This is going to allow you to see the time, set the time zones in a much easier fashion. Some hardcore Linux fans use the date command for everything, which is fine. But since the time that CTL released, I do prefer it because it's much simpler to use than the date command. But the date command is still a legacy command that can be used in some situations. I will not run these commands, at least not right now. I will do it later. So you have the passwd command. I will cancel it with Control-C. Control-C will cancel this. Passwd will allow you to change the password of the current user, as you can see. If I was the admin or the root user, I will show the root user later on. I don't need it right now. As a root user, I can change the password for any user of the system. Okay. But right now, if I run passwd as student, because that's who I am, as we could find out with the who am I command. Okay, I am student. So if I run passwd as student, I am allowed to change my own password. However, I have to fulfill some security policies by default, which is letters, numbers. It has to be an X amount of character sizes. So you cannot choose any password at all. You have to comply with the security policy of your current system, but you are entitled to change the password at your given leisure, unless someone changes the default security policies. But if not, then any user can change its password using the passwd command. You just need to make sure that you are using a complex password. Basically, that's it. Okay. Another utility that they like us to show you, it's the file utility. So one thing that you need to understand that there is a saying that says in Linux, everything is a file. Okay. What does this mean? Everything's a file means that literally everything is a file. Okay, so a directory is a file is a file, hardware components are represented by a file. So in Linux, everything is a file. And many files don't have an extension. For example, in Windows, we have the .xes for executables, .txts for text files, .xlss for Excel files, and so on and so forth. Here in Linux, extensions matter little to nothing, even though some files have a so-called extension, .something. It's not considered as an extension per se. We call it an extension because we come from Windows and have that heritage. So let's call it an extension. There's nothing wrong with that. But it's not an extension per se. In Windows, it has more relevance than in Linux. Okay. In Linux, it's just part of the text. It's just part of the file name. So if the file name is called .txt, it's an extension for us, the human being, but for the system, it means nothing. It's just part of the file name. It's useful, it's handy, but it's a little bit abstract for the system. Okay, and since everything is a file, sometimes there are files on different locations that are different, have different content. For example, I will show you a classical example, which is this one here and this one there. I'm sorry, this one. Okay, let's do this again to make things a little bit cleaner. Okay, cool. So if you see, the first one is an executable and the second one is a text file. So they have the exact same file name. They have the exact same file name. Okay, but they are very different file types. So one is an executable, which is the one I just executed to trying to change the password of the user. The second one, it's a text file. So they are completely different files with completely different ways to deal with each file, but they have the exact same name, even though they are in different folders. And the file system hierarchy, I will discuss this on a later chapter. They are on different folders. One is executable, one is a text file. So the file utility allows me to find out what type of file we are looking at. This is a directory, and so on and so forth. So the file utility shows us, allows us to visualize what file type we are dealing with. The next one is the CAT. Oops, sorry. Good thing I just did this typo, because if I do this, it's different from this. Okay, so in Linux, case matters. Okay, case matters. So if I do CAT, the CAT command is called the concatenate command. This command has several reasons to exist, but if you're going to see this one and going to check this one as one of the many examples that we can use cat for, and that is for taking the contents of a text file in a non-destructive manner. So if I do this, it's a text file, which means that I can just check the contents with CAT. There are other tools that allows us to see contents of text files, okay? But I will show you one next. But CAT, if you do this, it's almost impossible to make any destructive changes to the file, especially since we are not root, we are regular user. That will be completely impossible. But the CAT, even with root, unless you do something really stupid or really crazy, it's non-destructive. Other can be used the more command is similar, and the less command is similar. Okay, so more is less is more. You can use both, experiment with both, and you can then choose the one you prefer. So they also, the more and less also allows you to check contents of text files in a non-destructive manner. You have also the head utility. This allows you to see the first lines of a file. By default, you can see, let's do it the lazy way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see by default, the top 10 lines of a text file. You also have the tail utility that will show you the bottom 10 lines of a text file. So head top, tail bottom. It's like a cat or dog, right? Head and tail. And you can also customize the how many lines you can see with the -n. And in this case, I'm just seeing one. Okay. So you can do the head minus help, and you can get more assistance about that, and also the tail. So tail -1, and you will see just the last line. So head top, tail bottom, and you can actually see the head, the top of the file, or the bottom part of the file. Also have the WC command. WC command means word count. Okay, so let's say let's use the same file as reference. So you can see here lots of information. Okay, you can see here that you have this means lines, words, and characters. Lines, words, and characters. You can do the -L. This will just show you that how many lines. You can see the C for characters, and W for words. So as you can see, this file has 37 lines, which is composed by 90 different words, and this has a total of 2,113 characters. So this can be used in conjunction with other commands. For example, if I do something like this, and I can do the pipe means the output of the left command, it's input of the right hand command. So if I do it like this is going to get the output of this command and give it to this guy. So this guy is going to count how many lines this output created. So tail created 10 lines, which it's something we already know. So if I do the -n5 or 6, whatever, it created 6 lines. Okay. So tail means this is going to count how many, in this example, this is going to count how many lines the previous command created. So can we use multiple combinations of the left command and the right command? We will do this throughout the video series. So no need to force other examples because they just will occur naturally. Okay. Last but not least, on this kind of initial toolkit for the command line, for the bash, it's the command history, which is quite nice. So if I type history here, you will see how many commands I typed and which ones they were. So I have typed already 43 commands, and these are the commands I just typed, which is quite nice. So if I do exclamation mark and 35, this is going to re-execute the 35 line. So if I want to re-execute the command that I already did before, I can just say which line to re-execute, and he will do it. Or you can just select. This is using the graphical interface, of course. By using the graphical interface, you can select and use the middle mouse button. Nowadays, it's the wheel. So if you click on the wheel, it will just paste what you just selected. So I can select, click the wheel, select, click the wheel, and it was just paste what I selected. Or if you want to be a little bit more tech savvy, you can just do question mark and the number, and it will just execute that position. You can also use the up key and down key on your cursors. It will just scroll through the history. Okay, that's fine. Or you can do Control P, Control N, Control Previous and Next. It will do the same thing. So there are many ways of us to understand what have we done, what commands we did, and get kind of a history of previous actions that we just did using the history, the cursor keys. Okay, or well, there are other ways, but you can explore this as the week goes, as the video series goes by. You don't have to force anything right now. Let me just review my notes to see if I. Oh yeah, you can do Control R. Ctrl R allows you to search on the history. For example, if I type tail, it found the tail command. Control R tail, and you can just search on your command history for recently executed commands, and you can just redo it without having to type history and scream through with your eyes. Control R, and you can type something about the command. He will find it for you, which is quite nice, quite handy. Okay. Oh, and of course the tab completion. So let's say I want to do cat to the etc/pastled. Let's say I want to do this. Okay, so I can do cat /etc/pas, and I hit the tab key. As you can see, the tab key auto-completed. So it is better for you to experiment yourself, but the tab key will complete file names and file paths and executable names. For example, if I want to execute the pastled command, I type pass, hit the tab key, and he auto-completes. So get yourselves acquainted with this, because it's going to be a time saver for you, so you don't have to retype commands. And if you have commands that you use frequently, you just have to exercise your pinky to use a tab key to get more out of it. That's it for chapter 3 about using command line utilities. Chapter 3 or chapter 2? I'm sorry, chapter 2. How to access command line and first hints on how to use a command line. Like and subscribe if it helps for chapter 3. Subscribe to get notified for chapter 3, and I'll see you in the next one. Cheers, guys. Okay, don't forget to like and subscribe. It will help the channel to grow, and you get notified of our new content. Okay, so in the previous days we covered what Linux is and how to access command line. Today we're going to cover chapter 3, which is called the file system hierarchy and how to manage files on this type of machines. So to do that, I'm going to work with you guys with a screenshot here of a file system, a typical Linux file system. This applies to RHEL or Red Hat Enterprise and applies to pretty much any other Linux with some slightly variants, but for the most part, this is the same thing for most or all Linuxes for the most part. I'm going to look down because that's where the image is, so I'm sorry I'm not looking at you. So here you can see the typical components of a file system hierarchy. So each folder will have a specific role, or will have a reason to exist. This is not, the other operating systems are not different. Other non-Linux operating systems are not that different. They also have a file system type or a file system hierarchy created that will allow the files to be placed in a specific locations for specific reasons to exist. Linux is not different. So I'm going to walk you through a typical file system hierarchy. This is basically what all Linuxes use with slight differences, but this is going to be kind of RHEL focused. Not all folders are here. Some folders are not represented in this image, but this is kind of a starting point for the rest of this video series to make a little bit more sense. So typically, a typical Linux file system starts with this folder. It is called the root folder. Okay, this is the root folder. So if you are watching this in your phone, if you turn your video upside down, you will see that this resembles a tree growing from the roots to the leaves. Okay, this is basically what's happening here. The tree is growing from the roots to its leaves. This is not that different. This is a file system that grows or starts in the root, which is where most things grow from, right? So the forward slash means root. Then I'm going to go through these folders that are represented here, not in a specific order, not by order of greatness, just any order will suffice, will be good enough. I mean, you have two folders. You have the bin and you have the S bin. So bin means binary, S bin means system binary. So both of them contains binary executables. No surprises there. So they both contain executables. So, but typically the bin folder contains executables that most or all users can use, stuff that is basically harmless to the system. SBin uses are binaries used by the admin user or equivalent, the root user or equivalent. So in the SBin folder will contain, or the SBin folder will contain stuff that can actually do changes to the system. Typically in a broad image, that's how we imagine things. So if I go here to any box here, I'm using I'm sorry, capture is not working, or is it? Oh, it is. I'm stupid. I'm sorry. I thought this was not moving. So yeah, if I go to this box here, top left, and I need to pull this a little bit down. There. So if I can use, for example, use the passwd utility as an example. So I know where it is, but if you don't know where a specific executable is, you can use the do which command, and with the executable, want to find where it is, and this is going to show where it is. So which will show you the location of executables. So passwd it's on USR bin. Okay, why is that? That's because if you look here, there is these dots here. This means that the folders have moved. So if you are using quote unquote older systems, not that old, 5-6 years old maybe, you'll see that it's on a slash bin. If you are using a more recent operating systems, Linux operating systems, now it's on the like you see here, USR bin. That's exactly what you are seeing here. It's not of a big deal. Okay, you just need to find where it is, and it's the same executable, just a new path, but it means exactly the same thing. So as you can see, the passwd command, it's on the bin folder, so it means that all or most of regular users can use it, which is true. We saw this on a previous video. Now, if I do, for example, the IP command, which is related to network configuration, you will see that it's on the S bin. So this is anyone can use, only admins can use. So there are exceptions to this rule, of course. There are always exceptions to all rules. But basically that's being regular users as being system user. Okay, so without going through exceptions, which is would be time consuming, and we will find them as we go along. Being regular users as being admins, and the which utility will show you the path to executables. It's an easy way to find where an executable is, which is its full path. Okay, going back here. Now we have the /boot folder. The /boot folder is where the boot files are contained. Again, I'm sure you guys could figure this out on your own. The dev folder is a special folder. This folder, remember on a previous video, I said in Linux, everything is a file. So hardware components are represented by files on the dev folder. So it's not a folder we usually tamper with. It's not a folder we usually touch or do admin stuff in there. There are exceptions, of course. There are always exceptions, but the rule is the dev folder, I will not tamper with the dev folder. It just stays there, it lives there, and it will leave it there. The system needs it to work. The etc folder, it's typically where we find configuration files. For example, we will come across this throughout the week, throughout the video series. We will, for example, if I want to configure HTTP or any other service or of that kind, easily on the etc file folder, we'll find a file that configures that. For example, we can see the etc passwd file, text file that will contain the configuration files for user accounts. Home folder means that every user has a home folder. Okay, so if I go back to here to any system, if I do the pwd command, the pwd command will show me which folder I am currently on, and this is showing me that I'm currently on the home student folder. Okay, so if I was a different user, we will create new users in a future video. If you create a user called Alice, for example, it will have a home Alice folder and so on and so forth. So it's where people have their files and their folders on their own home folder. So it's like their corner to store files at their leisure. Okay. Again, if you look here, the tilde means home folder. So if I go to DTC folder and I get out of my home folder, if I do cd tilde, this will bring me back to my home folder. Okay. So tilde is kind of a universal meaning of home folder. Okay, that's why it shows tilde here and not a full path, because for the bash terminal, tilde means home. Okay, so this is normal. This will actually mean this and vice versa. Okay, so everybody's entitled to a home folder with an exception. The root user has his home folder on different location. So it's /root, not /home name. Okay, that's something to be aware of. That the root user has his own folder too, but it's not on home something, it's /root. Okay, so that's something to be aware of. You have the /run folder. The /run folder is a folder that is called runtime. Okay. Runtime means that everything that is stored on this folder, it's going to be deleted on next reboot. There are some exceptions, but let's not dive into that just now. Just imagine that run folder, when every time you reboot the server, the contents are deleted and rebuilt from fresh. The SBin, we know what it is. You have the TMP folder. The TMP folder, it's used to store temporary files. So something for the system to keep running, like you install a new package or something, it will use a temp folder to store some files. You have the USR folder, which contains the following folders: the bin, now you know, the SBin that you know, local is like everything goes there, like install a browser, local files will go stored there. You also have the temp folder, another temp folder on the USR folder, and you have the so you used to have a var temp folder. Another var temp folder is on USR temp. Again, you don't have to worry all that much about these exceptions, because it's not something you need to actually know. You just feel it and oh yeah, I remember this. It's fine. And with in time, you actually have time to memorize this. Then you have the var folder. Var means variable data. For example, websites, FTP sites, the log files are on a var folder. So this was kind of a broad overview. What I recommend you guys to do is get the system and explore yourself the contents of the folders and get yourself acquainted with the folder contents, or just use the system as normal. And in time, you will get yourself, well, with experience and with the system use, you will in the end get yourself acquainted and you know where everything is. So no, it's not a big deal. Now, one thing to understand here, or understand too, is the following. When we are working with these type of systems, there are two types of paths. They call it the absolute path, absolute path, and the relative path. What is the absolute path? The absolute path always starts with a slash. For example, the absolute path for the etc bin passwd. Oh, I'm sorry. So the absolute path for the passwd utility, it's usr bin passwd. So this is kind of the full path starting with a slash. Okay, so this is the full path to get to the passwd executable. The absolute path, it starts with a dash. It always starts with the root file system. It's kind of the absolute beginning of the path to a file or folder. Relative, it's relative because it depends on where you are. So let's say, let's find out where I am. I am on my home folder. So my relative path to get to the passwd, it's a little bit longer and more cumbersome. So it means that I have to go back to the home, back to the slash. How do I do that? cd dot dot. Dot dot will put me a level above. cd dot dot, I'm on the root file system now. Now I have to go to the USR, I have to go to the bin, and I go to and now finally I can find the passwd utility. Okay? So absolute path names always start with the slash, with the root file system. Relative are called relative because it depend on where is my starting point. So for example, let's still use passwd as a reference. So if I start with var, in var, okay. Now to go to the passwd executable, I need to go to the root, go to the USR, go to the bin, and then I find my passwd utility here. So absolute path names are usually, for the most part, are always the same, which means that, I'm sorry, I mistyped it. Okay, so the absolute path for the passwd executable, it's always the same, never changes, because it's always going to be this, it will never vary. Relative will depend, it's called relative because it depends on my starting point. Is if I'm here, to go to the passwd, I have to go back a few levels and up a few levels. If I start with the var, same thing, but relative depends on where I start. Absolute, it's always the same. The absolute path name never changes. Okay, the absolute path never changes. Okay, so I do prefer to use the absolute path, and well, it depends on the situation, but this one is kind of it kind of never changes, so it's kind of a certain thing, right? Relative, it's relative, so it will depend on where you start. I do prefer to use absolute path names because I'm forgetful and I get distracted really easily. So it's better to me to use absolute path names because they just never change. So they're more predictable, and it helps to my child's brain to work better. Okay, a few more commands that can help us to navigate a file system. You saw the CD. If I type CD enter, let's say, for example, I go here, I type CD enter, this will take me immediately to my home folder. So it's kind of a good shortcut to get out of where you are. CD home folder, it's kind of always the same thing. CD, it allows you to navigate throughout the file system. So CD means change directory. Other utilities that you can use are, for example, mkdir. This will allow to create a new directory. You just need to be sure that you have permissions to write on the directory. And since I am on my home folder, that's okay. That's a given. Okay. rmdir removes the directory if empty. So if the directory is empty, rmdir will remove the directory. So mk it's make, rm it remove, and usually this applies to most things inside a Linux box. mk creates, rm removes. That's kind of a standard thing to assume. Okay. Now, if the directory is not empty, so let's create a directory. Let's go inside it. It's currently empty apparently. Of course it is. I just created the folder. Let's create a file there. So there are many ways to create files, but let me show you the touch file, the touch utility. So the touch utility that you probably saw beforehand allows us to create files, create empty files. Okay, let's call it empty. Okay, this is a file that it just exists, but it's empty. It's a text file that is empty. Okay, let's try and check this out. Okay, so basically it's absolutely nothing. If I catch the file, it's empty, but it's a 0 bytes file, like you can see there. So it's a 0 bytes file, and it's an empty file. Okay, so it just exists. So what is the usefulness of the touch utility? So the touch utility has, I would say, multiple use cases. Let's say that one is this one. So if you touch a file that does not exist, it then exists but empty. Okay, it just exists. It just exists for the world to see. Okay, it's not having a specific use case to exist. It just does. Okay, then you can just do whatever you like with it. Another case, which is kind of the original use case for the touch utility, it's the following. So if I do the ls-l, which is a long list will allow me to see the details about the file. You will see that in this case, it was created at 9 a.m. 55 minutes. Okay. If I touch it again, so if it already exists, you will see that now it has its timestamp updated. Okay. So if you touch a file that already exists, it will update its last change to now or to a specific date. So if you do touch --help, like we saw beforehand, you'll see that you can specify the specific time or date with the timestamp option. But if you don't, if you touch a file that already exists, it will update its timestamp to now, basically. If you touch a file that does not exist, it's created with empty contents, unless you go to the help, you'll see that it has no creates option. So if you do touch -c no create, for example, the file does not exist but was not created. So by default, if you touch a file that does not exist, it gets created. Okay. If you touch a file that exists, it changes the timestamp to now or to a specific time and date that you specify. However, you can use the -c, and the -c will allow you to do not create the file if it does not exist. So it's kind of a multi-use case utility that you can use in many different situations, and we will use it throughout this video series. However, now the directory is not empty. So if I go back, if I try again the same utility, it will not remove it because it's not empty. So the RMD will remove directories if empty. If not, I have to use the RM command, and use this RM command very carefully, especially if you are the admin user, because this can create great harm to your system. So if I do RM directory, it's going to tell me that it cannot remove directory because it's a directory and it's not empty. So I can be very aggressive and do this, RF. Okay, this is going to remove the directory and all its contents. So this is remove without any regard of anything else, and F is force. So remove forcefully this directory. This will remove the directory and its contents. So use this action very carefully. Okay. Use the RM minus RF action very carefully, because this is going to remove the contents of the directory itself in a very aggressive manner. And if you are an administrator, you can even remove things that can be system relevant. Okay, so use this very carefully, the RF option, because this can be very aggressive and can delete things without you. As you saw, it did not offer any confirmation. So use it carefully, and if you are using the root user or any equivalent user, make sure to make sure to read the command multiple times and make sure that you are doing what you actually wanted to do, and you're not doing anything that can harm your system in a very serious manner. Okay. Now, I can also create mkdir directory and a subdirectory like sub1. This will not, I did a typo. This is going to create the directory. That's not what I wanted. Let's create this again. As you can see, it's not creating kind of a hierarchy. So if I want to create one within the other, you do mkdir minus p, you do dir 1, d2, d3. Okay, and now this is going to create. I'm so stupid. I'm using the wrong slashes. It's nice for you guys to see me doing mistakes. That's how you learn too. So let's do this again. I'm using the backslash and not the forward slash. So mkdir, let's do this. Let's do the directory /dir2. This is not going to create because I cannot create dir2 within a directory that does not exist. So the directory called directory does not exist. So there is no directory called directory. So I cannot create dir2 within this one, because if this one does not exist, how can I create this one? That's when d minus p come into play. This is going to create this one and then the next one, or however many you wish. It's a good thing I did this mistake, because you can see what I just said. When you do the RM command, make sure that you are looking at the command with attention, with detail, because I could make a big mistake if I was not noticing that I was using the backslash and not the forward slash, because on Linux it's a forward slash that you need to use. So you saw me doing a mistake. Good thing you learned with me that you should really read multiple times what you are doing before you do it. Like, to end this topic, let's just, well, not now, but this subtopic, let's discuss the cp command and the mv command. Okay, they are quite simple. Cp command, it's a copy command, and the mv command is the move command. Okay, so I don't think it's needed to show, but I will do it anyways. So I will do the touch, let's call it file1. If I do cp file1 to the red directory, it copied the file to there. So I don't think nobody's getting really surprised with this. If I substitute TCP by MV, it will move the file, it will disappear from its source, and it was placed on the destination directory. So copy will create a copy, move will move. We will delete the source and put it on some directory destination. So pretty simple. So these copies, these moves, I think at this point, everybody knows the difference between the copy and the move, but I will say it anyways. So copy will create a new instance of the file. It will copy it. Okay. It will keep the original and create replica. Move will make the source disappear and make it appear only on the destination directory. Again, use the move command carefully, because you may move things that, well, it can be, when misused, can create problems that you really don't want to face. Okay? Cool. Now, I advise you to get a system and get acquainted with the move and the CP, especially with the -R, which is recursive. This will copy all files and folders and subfolders, or move or delete. So be careful with the R. It can be capital R or lowercase r. It depends on the command. Also get acquainted with the -V option, which means verbose. So verbose means give details. Oops. Okay. So usually some commands are silent, so which means that they'll do what they have to do without without giving any feedback to the screen, unless you do the -V, which is verbose, and this will allow you to see more details on the screen while the command is doing its things. But explore the -- help of each command, now that you know what they do in a kind of a greater perspective, and get yourself acquainted with the switches that you might use more frequently. Okay? Cool. Let's finish this chapter up with something really cool, which is links. Okay? So let's talk about two types of links. Let's talk about, oops. Let's talk about soft links. Okay? And hard links. Oh, let me give you some space. Okay? So what is the difference between the soft link and a hard link? Let's start with soft link, just because, yes, no special reason to start with soft link. I could start with the hard link, which will be just fine, but let's start with soft link. So if you are familiar with the Windows shortcut, if you know what the Windows shortcut is, that's basically what the soft link is. So let's jump into the terminal here. Here we go. So let's just clean house. So let's do on -RF D2 this one. I don't want this one. Directly sub1. I don't want this one. Let's delete the D1. Blah 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 blah. And let's play with the directory. Let's play with this one. Okay. So I have here a file called file1. Okay, I have this file here, and let's give it some content. I don't want to use a text editor just yet. I'm going to use a technique called the redirection. So I'm going to do this. I'm going to do echo. If I do this, this is just going to type to the screen what I just typed. But if I do this, the greater than sign and to the file, this is going to redirect inside that file. Okay, in a way, I have just edited the contents of that file. So I added the hi message to the file, which is a text file now. Okay. So doing this on its own, it will put it to the screen. If I do like this, it will redirect from the screen to the file. Cool, eh? Very nice. Just be careful that by doing this, it will completely replace the contents of the file. If you want to add, you do like this. Sorry. Okay. If I use one bigger than, it's going to completely replace the contents of the file. All right. Cool. So the file has something inside. It's not just an empty set file. Okay. Now, let's say this file, I want to access this file not only through this folder, but I want to create a shortcut on some other place. So I can do, if I don't do this at first try, just bear with me because I sometimes have to do this twice. So let's do this. ln creates links, soft and hard, -s is soft link. Again, nobody's surprised with this, I'm sure. So let's say I wanted to create a link to this file on the var folder, and it's called file link. And it links to the home student directory file1. Okay, it's the other way around. That's fine. Like I said, I never do this at first try with success, but it's fine. I just can read permission denied. Okay, I cannot, as a regular user, I cannot write to the var folder, which makes sense. So I'll just put the link on my home student folder that I can write. Not homes. Okay, student, and I call file link. You have to be able to write on the destination folder. Cool. Now, if I go back to my home folder, you see that's a file link. If I do a long list with ls-l, which is long listing with the details, you'll see that this points to there. So if I do a cat to this, there we go. See? So basically this is, if you look here at this first character, you'll see an L. Okay, and L means link. Okay, which means that this file points to that one. So if I read out or write from here, I'm actually reading or writing to there. So if I do echo hi to bigger, I can cat and the contents are changed. If I go to the original location with the original file, you'll see that the contents have changed. So soft link is a shortcut, and you can soft link anything, files, folders, whatever you like. That's what is happening if I go here to the root file system. You'll see that the smin is actually a soft link to that new location, like you saw in the screenshot. So basically they are soft links. So this points to there and the bin points to there. So that's why I don't have to, like I said a few minutes ago, you don't have to memorize that stuff. Just let it happen, and you will naturally understand and internalize all that information in due time. So it's all good. Now, if you go to the hard links, so hard links can be a very long matter to discuss, but I will keep it very, very simple. So let's say hard links are alternate names. Alternate names. Let's try to write this, alternate names. Okay, it's a different name to the same file. Okay, so if I go back here, and of course this can be a very long discussion. Hard links can be a very long discussion, but I will keep it really, really, really simple. So if I go back to the directory, to the file we were discussing right now, okay. So this file it's on identity. If I go back to if I list the shortcut, oops, I'm sorry. You will see that the shortcut points to that one. So this is a file, completely new file with a special behavior that can actually point to a different file. Okay, so this one is kind of an arrow pointing to that file, which is kind of what you see here. Okay, if I look to the original file, this file here, it's kind of its own thing. So if I add here this option, which is the I stands for inode number. Long discussion, I will not go through this here, but the inode number, it's this number here, and this is a system-wide number that represents an ID of this file. It's like our identity card. Okay, so this is the number that represents this file. Okay, if I look to our arrow, the soft link, also using the I option, you will see that it has a different number. So each file has its ID, unless, so this is the ID of the original file, okay? Now, a soft link is an arrow that points. It's a new file that points to another file or folder. A hard link, it's an alternate name. So let's do this. So let's try, let's immediately do an example. ln, let's call it file1 hard. Again, if I mistake, do this in the other way around, that's just me. Okay, it's the other way around. I never do this right first time. I don't know why. If I go back to our original file, you see many differences. You see that this file still has its same ID, which makes sense, but this number changed. It's now from 1 to 2. It means that this file now has an alternate name, which it does because we just created it. So this is the original file. That's called original because it was the one I created first. And this is the hard link. So this one, okay, and this one, if you check here, they share the same inode number. So they basically are the same file, but with two different names. Now, if I can just, let's try this again. Let's do this the other way around now. And let's call it file hard 2. If I go back to this option, as you can see, all three are the same file, but they have different names. Okay? Which means that if I change one, let's call it hard, for example, and go to file 1. Let's say hard 2 and go to file 1 hard 2. I can just check the one that I did not change. So I redirect it to this, then to this. But if I check this, it will have the changes. Okay, because they are the same file. They are exactly the same file. Same file with 3 names, same file with 3 names, same file with 3 names. So it's just an alternate name to the same file. So it's to most applications and services, we are looking at the same file with different names. So one is a shortcut, one points to the other, and you can shortcut files, folders, whatever you like. Hard links can only be done to files, not to folders. And basically they are the same file with different names. Same file, same file, same file, different name, different name, different name. Which means that if I delete this one, which is the first one that existed, everything is fine because the other two still exist. Okay? Okay? I can delete the second instance just fine because this one still exists. Now we are on danger zone, which means that I have the single instance of the file now shown, which means that if I delete this one, file is gone forever. But I can just create a replica, not a replica, an alternate name to the same file. So let's call it file 1 hard 2 to file 1 final. I don't know. My imagination is kind of running out. Yeah. So now I have 2 instances of the 2 names for the same file. I cannot, remember this, I cannot link folders. That's impossible. You cannot do it. But files you can. And I'm doing this on the same, they are both on the same folder, but I could just do something like home, student, final 2, and it's there, final 2, and final 2 is here. You check the inode, this inode 993 checks with this one, which means that this alternate name for the file, now it's on a different folder. So it's just a way to can scatter alternate names for the same file, for the same content. So if I do echo final, whatever, to this one here, if I go to the one that has the other ones, they will have the change applied to. Okay, so hard links are alternate names for the same file. and soft links are shortcuts. So on hard links, you can delete all the replicas until you have only one replica, and then you will delete the whole file. But as you can see here, I have 2 hard links, but there is one missing. I know where it is. It's here. So I know that it's here. But if you see this, you see that 2 are here. A third one is somewhere on a file system. There are ways to find it. We'll see that in later videos. But for now, if you see 3, but only you see the number 3 there, but you will have only 2 instances in front of you, there is a third instance somewhere in the file system that you need to find. Let's disregard the directories, because the directories are a completely different beast. I'm talking about files only. Well, it was quite of a long video, but it was quite nice. Like and subscribe, it really helps. I will post more videos as fast as I can about this subject. Hope you liked it. Type down below on the comments any questions you may have. I'm happy to answer them. I'll see you in the next video. Don't forget, like and subscribe, it really helps. And I'll see you in the next one. Cheers. Yeah, hi. So let's dive in immediately on chapter 4, which is getting help in Red Hat Enterprise Linux. So this is going to be short and sweet, because I'm going to show you 2 methods of obtaining help. I'm not going to go into deep detail in either one, because it's something we will use and reuse onwards on the video series. So I'm going to show them to you, and in due time we will just explore it in practical terms. So really short and sweet. So I really recommend you guys use 2 methods plus 1. You will understand why do I say plus 1. So the first method to get obtaining help is, let's say, for example, you want help about the possibility utility. So you have seen this before. You type -- help, and you have here the immediate help about the specific command. Or you can do the man pages. So the man pages is kind of the one all-be-all tool to get extra help. So man possibility. And you have here all the details. We will dive in many man pages of many utilities throughout this video series. So I will not go into much detail right now, because it's really not productive to do this right now. I will do it when we need it. So the man pages, but I will not end it here, because there's something special about the man pages that I want to explain you right now. That makes sense to be explained right now. And it's regarding to the possibility command. So if I do man possibility, you see here in the title that says user utilities, but we will also have a possibility text file. Okay. So if I do a man possibility, I'm getting help about the executable and not about the text file. So what if I want to use or see help about the text file? So let's use a little bit of an exception, and let's do man. So let's make the manual pages for the manual pages. Makes sense. I will not go through this with you guys, but I will stop here in this section, because the man pages have paragraphs. Okay. If they call it paragraphs or sections, it doesn't really matter that much. You have paragraph 1, 2, 3, and so on and so forth. For now, let's focus on the 5 and the 1. 1, like you can see, is our executables. 5 are file formats. Like, for example, etc passwd. How convenient. So if I do man passwd, I'm getting the help about section 1, which is utilities. However, if I do man 5 passwd, you see now I'm seeing section 5, which is about file formats manual, which is about text files and its conventions. So if I do man passwd, by default, I'll go to the binary executable help. If I do 5, I'm getting help about the file text convention. So this is the main pages are very powerful, but like I said, we will dive in its sub-functions or extra stuff throughout the video series. I will not force you down your throat all this information right now. Just bear in mind that you have the -man help, you have the man pages. Man pages have sections, and the sections we are going to explore the most are executables, which is this, or we can put the number 1, but it's just wasting time, or file text file conventions. Okay, so Here I will see the contents and how it's built the text file passable D. Okay. And here I'm getting help about the executable. So bear in mind that there are differences about this. Of course, if passable D was only the executable or only the text file, this wouldn't be a problem. But since there is this coincidence of being an executable and a text file, this may be coming handy to you guys. The third method is Googling, but I will avoid it as most as I can. And I think I will avoid it at 100% to Google it. But, you know, Google, it's sometimes useful and there is no shame about it. That concludes chapter 4. Experiment with the minus help and the man pages on your own systems. And I'll see you in the next one. Like and subscribe, it really helps. And, well, please do. So today, the chapter I'm going to cover with you guys is chapter 5, which is on the official textbook. It's called Create, View, and Edit Text Files. And since in Red Hat Linux and all other Linuxes, to be honest, the text files are kind of the bread and butter, which means that when we want to make, I mean, I'm not going to say all of the changes, but most of the changes on the system, like change service behavior, for example, create users, create groups, so all that stuff like that, we will for the most part touch some kind of text file for that. And that's why, well, creating, editing, and what is called create, view, and edit text files, it's a very relevant skill to have. Oh, I'm sorry. It's a very relevant skill to have because it's kind of a bread and butter of a day-to-day system admin of a Linux box. So I will not go into too deep of a detail about this because, again, like I said in previous videos, things will just happen. I mean, the need for editing text files will just happen. So I will do this so often that I will use those moments to then deep dive more into the tools themselves. So, but at this point, let's just discuss some of the major ways to view, edit, and change contents of text files, and some text files as an example. So let's just start directly on the console. Let's start with something we already know. We have already seen on previous videos, which is the cat command or the cat command. So the cat command, if you check the main pages, those that we have also covered on previous videos. So if you check the main page for the cat utility, you'll see that the cat utility serves multiple purposes, but one of which that we're going to use for at least for the following seconds is to being able to check the contents of a text file without being destructive. Okay, so we will be able to actually check the contents of a text file, and doing this like this, it will be non-destructive. So let's, for example, check the etc passable D file. So you already know what the etc folder contains. So the etc folder contains, for the most part, config files. So not only, but let's use this as our baseline. So if you are looking for a configuration file for something, for a service application, whatever, if you look first on the etc folder, you're most likely to get lucky and find a file there. And the passable D file, it's a file we're going to explore on the next chapter, chapter 6, if I'm not mistaken, which is where we're going to learn how to manage users and groups. So the passable D file is going to be one of the main files we're going to explore. So going back to the cat utility, so you do the cat, for example, cat etc passable D, and you get checking the contents of a text file in a non-destructive manner. And since I'm using a regular user, I am not able to destroy the content of this file anyways. But even if I could, if I have the rights to do so, the cat command used like this will not create problems because it will not create it will not make changes to the contents of any file if used like this. Okay, so the cat it's one way to check the content of a text file in a non-destructive manner. We also saw the more utility. Okay. And you also have seen the less utility. So more than less, some people say that less is more, and well, it's a kind of a private joke, but We can use either one to check the content. Well, either of these three, cat more or less. I will strongly suggest you to experiment with all three, and you will find which one is the better for you. It's not a matter of which one is better or which one is worse. It's just a matter that all three work for us, and we'll just need to find the correct moment to use each one of them for our own profit and benefit. So I will use cat for the most part, not because it's something that cat is better than the others. It's just kind of an addiction of mine. Cat was the first one I learned, so cat is going to be the one I will use the most, but no special reason, no technical reason, just because it's the one I prefer. You should check cat more and less, and you will then make your own choice about which one do you actually prefer to, and make your own choice for which one is your current and recurring tool to come back to. Okay, so that's also always a good thing to test. It's experiment with the tools and pick one that you prefer and stick with that one, because it's going to be the one you will trust. Okay, so you know how I will show you another tool, because it's kind of something, it's inevitable to get to that tool. But let me show you one way to change the contents of a text file. So I will get this possibility file, a copy to myself. So I'm going to copy from its current location to my home folder. Okay, so on my home folder, I'm here, and the file should be there. There he is. Okay, so now since it is in my own home folder, I can now tailor the contents. I can change the contents because it's on my home folder, and files that are copied here, I am entitled to change them. This is still the possibility file. This is still the system file, but it's a copy of it. So it's not in the etc folder. So now it's on my home folder. It kind of lost its meaning. So it's not a system file anymore. It's just a regular file because it's on my home folder. So like I said in previous videos, in Linux, everything is a file. So, but the file location actually matters. So the possibility file on the etc folder has a special meaning. It's a system file with relevance and a reason to exist. But now a copy of it that was on the etc folder now was created on the my home folder. The contents are the same, the file technically is the same, but since it's on a different location, it lost its meaning, and now it's just a regular text file. So let's say I want to change the contents of a text file. There are, let's say, two major ways to change the contents of a text file. Let me just create a copy of the copy, okay? You'll see why in a second. And now I will just change the contents of this text file. Let me just maximize the size of my window without going over it. Nice. So let's change the contents of this text file, okay? Without using a dedicated text editor. So let's check the contents first. You know what's within it, but let's check it anyways. So let's say I want to add something to this file. It can be, since this is a regular text file now, it can be anything. It will just not matter all that much. So without using a dedicated text editor, there's a way to use it, and I have used this before in these training videos. That is the redirect technique, which means that I'm going to use two symbols, this one and this one, the bigger than and double bigger than, and you will listen in a second. So if I go back to the echo utility, which is, it says hi, so echo will just put to the screen what I just typed, which is, it can have these use cases. But in this case, I'm going to do a bigger than to the file. Okay. What happened now is that the contents of the possibility file were overwritten by my redirection, because this symbol will destroy the destination file. So all the contents of the destination file are going to be substituted, replaced by the output of the echo command. Now you understand why I did the copy. But if I do the bigger than twice, this will add to the file but not destroy it. So all the file contents words are still there, but I added a new content that is my message, hi, or whatever the case. which means if I know well enough the contents of the file, I'll just copy this to save some time. And again, this file now it's on my home directory, which means that it's just a text file. It serves no special purpose except being a text file. So I'm not going to affect the performance of the server. I'm not going to inhibit its regular performance, its regular use case, because it's a regular file. It's a text file on my home folder. Even though it looks like a system file, which it does, it's on my home folder, so it's doing nothing except it looks like one important file. So if I want to add something that looks like the contents of the file, if I know what the contents of the file usually is, so I can just I can do this, and if you look, I kinda edited this file, adding new content. And usually in Linux, when I add content to a file, it is going to change the behavior of something, an application, a service, whatever the case. So in this case, I am adding a line that I know what a file usually contains. So this line would have an effect if this was an actual system file. In this case, it's not, because it's just a text file in my home folder. But in the next chapter, chapter 5 is kind of the last chapter in how to generally use a Linux box. Chapter 6 and beyond, it's when we actually make things to tick. So if I was making a change to the actual pass.tld, I could use this technique to add some contents to it. But be careful, because if you do a mistake, if you forget to add the second bigger than, you will completely destroy the contents of the text file and add only the thing that is new. So even though it's useful because it's fast, it's non-interactive, you just bam to the file and you're done. Just be extra careful when you do this, especially when using a user with privileges like the admin or the root user, because you may actually create problems, and you will not be able to see. It can affect the machine in a negative way. But this redirection can also be used not only to change the content of a text file, but also to change the content of the output to the screen. For example, let me see if I can do this from memory. So if I do something like use the find utility, well, I think it's the first time we see the find utility in this video series. But the find utility, if I say nothing about the find utility, I'm pretty sure that you guys will just figure it out yourselves. What do you think the find utility does? Think about it a little bit. It finds. Yeah, it's kind of a search. So an easy way to use this, it's to, let's say, for example, where to find something and the criteria, like file name, and I'm going to call it FS tab. Okay, so in other words, I'm going to find on this folder a file with that has the name FS tab. I could search for file names, file sizes, permissions. Well, the find utility is very powerful. You can just man and check the details about it, because now you know how to use a man utility, and now you know that man exists. So you could just man the find utility, so you can actually check the story behind the find utility. But you can find by file name, file size, file extent, file permissions, many criteria, file owner, etc. So in here, I actually see that I have two types of information being thrown at me. This is considered a success because the student user was able to find the file here, and I can confirm that the file exists and its location. And this can be considered as errors. So I'm not able to, my student user is not being able to search within certain parts of the file system, which also makes sense. This can be considered clutter, visual clutter. So I could use similar technique that I used to redirect to a file to clean up a little bit the output. So let's say if I do this, number 2 represents the errors. It's called the standard error, okay? And I can, for example, send this to a file, find errors. Okay, what happened here? It was the following. Now I'm seeing on the screen only the successes. The errors were redirected to a file. Okay, so it means that now for example, let's say I have run this command before. I know I will see some permission denied. That's something I know as a given. That's something I just know. So it means that I want to eliminate the errors because I know that I'm going to get them. But all this information, it will just create visual clutter. So I'll just clean up the output a little bit. Okay. I only see the successes, and the errors were sent to a file. So I don't see the errors, well, unless I see the content of the file. If you want to be a little bit more aggressive in a good way, you can do this by sending information to the dev null. Okay, this is going to send all. In this case, I pick the errors and send it to dev null. Like we saw in a previous video, the dev folder is where the files that represent devices are placed, and the null file represents kind of a void. It's kind of a black hole. So everything you send to the null is considered a void. It's nothing. So everything you send to there, it's going just to disappear. It's not going to be held in disk, memory, or whatever. It's just to be destroyed. I'm not going to say in the next second, but as soon as possible, the contents are just going to be completely destroyed. In this case, I'm saying all the errors that the find utility is generating, please send them to nowhere. So it's not getting saved in the file, nothing of that sort. It's just disappearing. It's getting rid of. So I get a clean find result, and the errors that I know I'm going to get, I don't care about them. I just don't want to see them and send them to somewhere that is not going to keep them. So this is very good for people like me who can get this strategy really fast and really easily. So if I get my output really clean, it will also help my way to interpret the output. So I just send all the errors to somewhere else. I can keep them on the file or just destroy them. So I can also do something like this. So notice the difference. If I do this, I don't see the successes. I just see the errors. Why? I'm redirecting the successes to a file. Okay, the file is called find errors, but it doesn't really matter the file name. This is redirecting the success, which means that I'm not seeing the successes anymore. I'm just seeing the errors because this is redirecting the successes. If I check the find errors file, you'll see that I have the success. So if I do the 2, I'm redirecting the errors. If I do the bigger than, I'm redirecting the successes. So this kind of, it may look dumb, but sometimes you want to look for the errors so you can troubleshoot something. So you say, oh, okay, all the success messages, I don't care because I know it's working. I just want to focus on the errors. So I will not see the successes. I'm just seeing the errors so I can troubleshoot my issue. Of course, the find utility is not the issue per se. You guys get that. But you kind of get the idea about, or behind all of this. Okay. Let me just check my notes because I just removed my notes from my screen and I don't want to forget nothing. So let's go here. La-di-da-di-da. So you can use multiple combinations of this. And again, I recommend you guys to experiment with this. Check the month pages and create your own toolkit. So you can create your own sceneries and create your own toolkits to make this work for your own benefit. Another thing you have checked out before on previous videos is the pipe. Well, the pipe allows us to get the output. Let's use a file we have here locally, since we have. So let's get the possibility 2. It's the pipe. So the output of the leftmost of the pipe, it's the output it's getting. It's going to be sent as an input to the right one. So As you can see, the output of the cat file, it kind of fills the screen. So, but if I can send it to the more, for example, it will just be managed by more or by less. So the output of the command of the left-hand side of the pipe is going to be sent as input to the command of the right-hand side. Another very common use case for this is to use the grep utility. So the grep utility, I like to call it, it's a mess cleaner. So the grep utility allows us to get an output of a text file, especially text files, which are usually messy and very confusing. And you can be able to filter out information that we get from certain files. So for example, let me see if I can find the student user on this file. And I have two students, the student and the student 2. Perfect. So the grep utility, again, I will not go into deep detail right now about the grep utility. I advise you to get the man page and explore it yourself. But the grep utility allows you to find text patterns on a text file, which can be quite useful. So the grep utility is using and uses a thing we call regular expressions, and regular expressions are not a Linux thing. They are just a thing that is used in Linux, Cisco, programming languages, etc. So regular expressions are a way to find text on a chaos. Okay. So let's say I want to find using grep. I can use I don't know what it's called in English, but you guys know what I mean. Or I can just use the commas. Okay, I can find the exact expression, but also can do the -v, which is -v is the inversion, everything that is not. Okay, and you can use also the -i. -i can be very useful. I is case insensitive. As you can see, I type lowercase student, uppercase student, and he finds both. But if I remove the -i, now it does not find it because student is typed in lowercase. See? So -i can be helpful if you are still trying to fiddle with the file. You're not sure how the file is typed. If you're looking for an uppercase stuff, if you're looking for lowercase stuff. Of course, if you use the casing, the correct case, it's going to make your searches more accurate, yes. But if you are still looking for something that you don't know exactly what you're looking for, it's nice to use the case insensitive part. So cat or experiment with cat until you find the better use case for the cat for yourself. But it's very useful, and I will use it throughout the video series many times, and you'll see me using it in other contexts other than just dumping to the screen everything that I know about cat and grep, which makes little sense at this point. Okay. Now, going back to this, let me find, I don't know, maybe not the find. Let's use the echo again. Okay. Or no, let's go to the find. I think the find is also a good example here. But let's find an example that is of the simple sort. Okay, this one here. So this is cool, but the thing is, or when I just filter out the successes, this is cool. But for example, if I do this, then the successors are on the file, but I don't see it on the screen. So this is kind of a thing that can happen. So yes, I have filtered out the successes. Okay. But now, I don't see it, which is kind of the intention. But this is a very aggressive redirection. So this is kind of, you have to choose. Either see it on the screen or send it to a file. You don't get to have both. So if you send it to the file, you don't see it on the screen. If you see it on the screen, you don't send it to the file. So it's kind of you have to pick. Well, it's kind of you give away something to get something else back, unless you use a utility called T. So for example, let's do something like, for example, let's do this in several parts. So let's do ls -l. This is no surprises for you. If you do this, I see nothing. See what I mean by the compromise? I either see it and not send to a file, or send to a file and not see it. if you want to have the best of both worlds, what you can do is you do the pipe T, you say ls out T. What happened now is I'm seeing it on the screen, but I also created the file. See? So T, it's a literal T. It's a cross, which means that the input comes from the bottom part and gets duplicated. So let me just do a quick and dirty drawing. So if this means that this means T, it means that I send input here and it gets duplicated. That's why it's called T, because it's a T. Ah, nice joke, right? But the main thing is, if you do it like this, okay, this is going to send to the screen and a copy to a file. So you get the best of both worlds. You see it on the screen, and you are also sending it to the text file. So no compromises here. You get the best of both worlds. You get it to the screen, and you also get it on the file. So again, just fiddle around with the T utility. I will use it more often. I will use it more in the rest of the video series, and I prefer to use it on the correct context and less instead of just dumping it to the screen for guys just to absorb. I will use it more times. I will use it in other times, and you will see me using it in the correct context. Now, last but not least, in this chapter 5, I believe, yeah, chapter 5, which is create, view, and edit the text files. It's kind of talking about the elephant in the room, which is that what are the text-based text editors. There are several text editors. You have the VI, you have the VIM, you have the Pico, you have the Nano, you have the Emacs, etc. Okay, all of them are fine. I'm going to use the V and the VIM because it's what's included in official training, and it's also the one I use the most often. So again, I'm not saying which one is better, which one is worse, because that's a conversation. I think it's just a waste of time. You just pick the one you like to use and use that one. I like to use VI or VIM just because they are kind of historically the big ones. And usually the VI or the VIM, one or the other or both, are usually available on most situations on the Linux box, including troubleshooting of stuff on the boot, troubleshooting of services. Troubleshooting environments will always have a VI or VIM of some sort. Pico and MX probably not. And also the VI and VIM are used all across the board in many Linuxes and Unixes. So if you know VIM, or VI, you kind of are at home in most situations, if not all situations. The one that was originally created for Linux and other Unixes was Emacs, but Emacs was replaced by VI by a very stupid reason by today's standards, which is VI was smaller by a few bytes. So again, saving some bytes was big 30 years ago, 40 years ago. So that was the main reason why Emacs got replaced by VIM. Nothing technical. Well, this space is technical, of course, but nothing too special. Just to save a few bytes, and that's why VI became the de facto standard nowadays. So from here to our end, throughout the video series, I will use VI and VIM, not Pico, not Emacs. But if you already have a workflow of your own where you use Pico, Nano, Emacs, or any other, I mean, if you had success until now, keep using it, but keep an eye out for VI or VIM. Once again, I am not going to go into too big of a detail about VI or VIM at this point, because I will use VI and VIM throughout this video series. So I will use it in its proper time, which means that I will not have to force anything down your guys' throats. You will just see me using it normally, and you pick up from there. So what is the difference from VI and VIM? Well, it depends on how you see it. There are similar tools. If you know how to use one, you know how to use the other. If you are like a regular user, you are kind of motivated to use, well, then in this case, I don't know, it's not created, but in some Red Hat boxes, they have an alias that means VI equals VIM. So you're kind of encouraged to use VIM. Let's see what happens when I use VI here. Let's use the possibility too. So this is VI, nothing great, nothing special. And I use VIM. They are basically the same tool, okay? VIM has some graphical enhancements, some enhancements on certain tools. But for the most part, what I'm going to use here, you can use both and it's the same thing. However, if I VIM the actual text file on the etc folder, you will see that the difference, an obvious difference. So if I use VI, it's basically the VIM. Like I said, in modern systems, you are encouraged to use VIM, not VI. No special reason, just yes. Now, if I check, if I let me remove these two files here, okay, and let me make a fresh copy from the original file from the etc folder to where I am right now. Okay, so the dot means current folder. So basically, I'm copying this file to my current folder. My current folder is my home folder. So in other words, I'm copying from here to my home folder. Quite nice. So if I do VIM to the file on my current folder, you see no colors. But if I check the VIM with VIM on its default location on the etc folder, you will see colors. So this is VIM being VIM. Okay, he knows that the possibility file on the etc folder is a special system file. But the possibility file, even though it had the same exact contents, but it's on the home folder, it's just a regular text file, like I said a few minutes ago. So no colors because it's just a regular text file. Colors because it's a system file. Okay? Quite nice. And the colors can be quite handy if you are like me, a little bit distracted, and because I'm not going to be able to save the file, but if I delete this, well, this is not going to be very obvious because the possibility file, it's very specific, but you will see other examples as we go on. Those color codings are useful for you to know, hey, look, wait, this was green, now it's black. Why? So it kind of makes your brain tick. Let's try a different one. Maybe I get luckier. Let's try. Like I get the warning, I cannot change this file because I have no rights to do so. As you can see, swap, now it's yellow. So it looks weird to my eye because yellow, it's not very, or red. So it's VIM telling you, okay, this SP, it's nothing, default, it's nothing, NNE, it's nothing. So be careful because these words mean nothing on this file. So VIM has some sort of knowledge of system files and their contents, and it's going to color code them so I can try at least be alerted to something that could be wrong on this file. But the possibility file on the etc folder, it's just a regular file, like I said. So I can just use VI or VIM to edit this file. And since this is in my home folder, I am entitled to change it because it's on my home folder. Now, how do I use this? Well, again, this is the short version because I'm not going to go in much detail right now because I am going to use VIM more often. So if you want to edit an existing file, well, it's just VIM and the file itself. I think it's not surprising. If you want to create a new file, just create a file name. It's a new file. Pretty nice. Now, to start to add contents, you just press the I key to insert. Anywhere inserting. Pretty simple. Now, let's say you want to exit VIM without saving. You don't want to save the contents of the file. What you do is escape. It's going to put you in command mode. If you are a proper system admin, you just hit escape multiple times because once it's not enough. Then you type a column and you type the Q command, lowercase q. The Q command, it means quit. And it's going to say, you did not save before quitting. I know, but I want to exit anyways. So I want to exit without saving. So the exclamation mark is kind of the one all be all, do it and shut up. Quit, I know I haven't saved, but get me out of there. Okay? So it means that the file was not saved. Insert, blah, 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 escape, column, quit. I know, column, and I quit. If I do want to save, I do the escape column, and I use the double key. This will write. Done. Then I can do a combination with this double Q. This is write and quit. Or if I am lazy, because I am, I can just use the lowercase x. This will do the same as write and quit. Pretty simple. Now, if I edit a file that exists, as you can see, it's the same thing, but I'm editing a file that already exists. But the logic applies the same. To make changes, I need to have the proper rights to do so. So a regular user can change files on its own home folder. So I'm good to go. If I was unable to save this file, I will just get the red warning in the bottom saying, no way, Jose, you cannot save this file in a shape or form. Now, if you look here, you'll see indication of the column and the line. So I'm on line 12, 9, blah, 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 and then column 6, 7, 8. So this is going to show me the line and the column of the file where I am at right now. Line, column, line, column, okay? Which means that, let's say I want to go to line 10. Fine. I can hit the escape key multiple times. Well, once it's enough. I'm just joking. You do a column and you type the line number. So let's go to line 16. There we go. I am on line 16. Column, line 10. I'm on line 10. Cool. Now, I want to make my changes. Well, I hit the I key and I just need to behave like a regular text file. Pretty simple. Now, I want to undo. Important. So I hit the escape key and I hit the U to undo. Undo. Pretty nice. Undo. Okay. So let's open this and let's say I want to copy the operator line, this line here, line 10. What do? Escape key, and I hit the Y key twice. Y for yanking. I'm yanking the line, and if I hit the P key, it will paste. Pretty nice. Undo. Pretty cool. Now let's say I don't want to copy, but I want to cut. So there are two ways to cut. This is my preferred method. Escape, you hit the D for delete, the D key twice. Oops, I just fat fingered it. DD, DD, DD. Undo. Or do 4DD. This still is 4 lines. Undo. The other way is to use the C for cut. So, sorry, C is cut and copy. So Y yanking is copying, C is cutting. So if I hit the CC, I have cut, and now I'm already in insert mode, ready to put something in its place. Undo. So CC cuts, opens the line, puts me in insert mode. Escape, undo. So both operations, or well, 3 operations to be honest. The yanking, the cutting, and the DDing, Y, C, and D, they all copy to the clipboard. So it means that if I do CC, I can do escape P, and it pastes. Okay? CC, escape P, and it pastes. See? Or if I do DD, oops, sorry. If I do DD, I can then escape P to paste. Even though it deletes, it puts it on the clipboard. Pretty nice. Just the last tips I'm going to give you for now are, if you hit the insert key, it's going to put you in insert mode in the beginning of the line. If you hit escape A, it will put you in insert mode in the end of the line for append. Shift A is going to put you in the end of the line so you can start inputting text. Shift A. Okay. Sorry. If you hit the O key to open will open a new line and you are ready to insert. Or you can do Shift O and we'll create a new line, but on the top, or not on the top, above the line you had selected. So I'm on the games. Shift O over it, O under it. Okay. Insert in the beginning, Shift A, append the end. So many ways to get new information to the file. I advise you to review view this video again just to get all the details and review it as many times you wish. Like and subscribe, it helps, of course. So let's save it. So escape, right and quit, save. Or without saving. Okay? So, much to learn. Watch the video again so you are completely within all the details. We will use these tools all over and over and over again on our future videos. The next video is going to be about creating users and groups, and it's going to be a perfect example of that. So view this video again, review the piping, the redirection, the VI and VIM. We will use these tools again in the future videos. But it's a good skill to have before you actually go and watch those, because I will not explain anything much further about VIM. I will just use it and you will learn like that. Sorry. Like and subscribe, it really helps. Please do like and subscribe, it really helps to get the videos out, and I'll see you in the next one. Cheers, guys. Okay, cool. So don't forget to like and subscribe. It really helps to boost the channel and really helps to boost the videos to reach more people so they can enjoy it. And of course, benefit me by growing the channel. You guys can understand that. So what we have today here in our list is that we're going to cover chapter 6, which is manage local users and groups. Okay. So until chapter 5, more or less, we kind of managed to create a somewhat solid toolkit. What I mean by that is now we have a solid base to work with. We know our tools, we know our text editors, and my other is clipping a little bit. So we know our tools, we know our text editors. So we kind of know, or we kind of have a good solid base to work with in terms of what tools to use in the right moment, right? So let's start to put those tools to use with some or for some practical applications on that. And in this case, we are going to cover the manage local users and groups, and let's dive right into it. So let's go directly to the console. So far for I think, I don't remember exactly, but so far for most, or for the 100% of our exercises and our examples, I have used a non-root user, which is the student user. We have discussed this before in the previous videos. Go and check them out, because it was just it was not needed to use anything else except a regular user to test those tools. So we did test the many tools. I don't remember all of them. We did test the text editing stuff. So without actually needing a special user except a normal user like the student user. So right now we're going to start to do some stuff that really requires us to have some sort of admin rights. So let's start with that. And again, let me stress this out. I have said this before on previous videos, and I'll just stress this a little more. That is, don't forget, this is just kind of telling you guys what's more relevant. I'm not telling you guys everything. You should dive into the man pages. You should dive into the help pages. You should try this yourselves and expand your experience with this type of stuff. Don't forget, you need to experiment to get the full experience, so to speak, right? So I'm going to give you guys the tips and give you the fishing rod, so you can just fish yourselves and get your own food in a way of speaking. So let's start by showing you guys two ways to get what is called admin access. So to get access to a user that it's actually authorized and entitled to do admin stuff. So it has greater rights on the system. And in Linux, usually we kind of go to, I'm not typing in there. Okay. We go to the root user. So the root user is kind of the user we are looking for. Come on, brain. So you can do this type of stuff. And we're going to show you two methods. One is the su method and the other one is the sudo method. They are different from one another. And again, you should experiment with both so you can then decide which one is the best for you. Okay. So let's start with the su method. Again, this is not in a specific order of importance. I'm not telling you that this su is more important than the sudo. Nothing of that sort. It's just an order. That's it. I cannot speak about both at the same time. So it's just that. So the su, many people think that su means super user, because super user, it's another name that we give to the root user. It's also called super user. It's kind of a non-official alias for the root user. But su does not mean super user. Su means substitute user. Okay, so it's not something. It's not kind of a deal breaker, but it's nice to know. So this is called substitute user, or some people call it switch user. So it's not super user, but if you want to call it super user, who am I to tell you not to do so? So if you like the name super user, keep using it. It's fine. Just understand that su means substitute user or switch user. And by using su, I can become any other user in the system if I have the rights and the password to do so. So I am the student user, obviously, and I can just substitute myself, hence the name substitute user. I am the student user. I can substitute myself to become someone else. And by becoming someone else, I can and I should include the root user. Okay, so I can do something like su root, and this is going to allow me, if I know the password, to become the root user. So in order to become the root user, I need to know the root's password, and it's, well, I'm not going to tell you my password, of course. And now I am the root user. Perfect. Okay. So now I am entitled to use the root rights, like is shown by the hashtag, like is shown by user ID 0. Okay. So right now I am for all intents and purposes the root user, and I can do all the tasks that a root user can do. Okay. So how do I go back to my previous user? So if you think about it a little bit, you kind of started by being the student user. Oh, I'm using the wrong tool. Let me just click. We were the student. We logged into the system using the student user, and now we kind of swapped to the root user. From here, I could swap myself to any other user in the system. So how can I go back to the student user? It's kind of like going one level back, right? So in order to do so, there are several ways to do this. You can type the exit command. Okay, you just can type exit. Or if you are lazy like me, you just have to do Control D. Control D is the same thing as exit. And now I just went back to my previous shell. So this is my student shell. By doing su, I spawned a root shell. Okay. So by typing exit or by typing Control D, I am back to my previous student shell. So I went back to the student shell. Okay. If I do Control D again, I will not do this because this will just be a time waster. But if I do a Control D again, then I am on my original student shell, right? If I do Control D, this is going to log out. Okay. So if I do a Control D on the last shell of the tree, let's call it like this, I get logged out. So I will not do that because if I get logged out, I need to log in back again, and it's just a time waster. Okay, so let's do this again. And I could easily do another su to someone, for example, back to the student. And if I do SU with the root user, if it is the root user to SUing to someone else, you don't require your password. You just don't. Okay. Now I can do just Control D again, and I'm back on the root on the root. Control D. I'm back on the student. If I do it again, I am logged out because it's the last shell I spawned. I will not do Control D because again it will be just a time waster, and we should be fine. Another way to do this is by typing a dash. By typing a dash, what you are doing is that you are loading all your environment variables as root. So it's going to give you a more root-like feeling. If you look at my previous attempt here, you'll see that even though I kind of looked like root, there were still some student stuff left behind. That's because even though by doing SU root, I was root, so I gained all the rights to be root. I did not, so I could do any admin stuff, no problem. I did not get loaded my environment profiles. And environment profiles, it's like the path profile, the aliases, environment variables, stuff that it's personal to the root user does not get loaded without the dash. So if you put the dash, everything is loaded into the new session. So if you add the dash when you upgrade or whatever, if you SU with the dash, so all the environment variables and environment stuff, it's going to be loaded with you. So you'll get the real true root-like login feeling, the rights and all the environment feeling. So I do use the dash. That's kind of muscle memory. I do SU dash root to get the root access. Another way to get root access is to do something as simple as sudo dash and you type in the password. Okay. So if you say nothing about the user you want to become, SU assumes you want to become root. So as you guys saw, I did not type the root user because you don't have to. You just do SU minus. Since you omitted which user you want to become, you are by default it's root. So it's a simple way to get root access. You just type this. But bear in mind that you can become any other user. I don't have any other users besides student or root for now, so I cannot become anyone else. But if I had, and I will have soon, we'll just do su minus user and become that user, and I will show that in a second. Okay, so that's one way to get root access. Another way to get root access or root-like access is by using the sudo command. You just type sudo and any command. For example, let's use something harmless like the ping or the IPA, maybe IPA. Since it is the first time I use the sudo command with the student user, it's giving you some warnings because this tool, it has to be used with respect and has to be used with care, because you can do lots of things that can be harmful because you have much power using the sudo. Now it's asking me for the password for my current user, and then it's telling me that you are not entitled to do this. Okay, so basically what I was trying to do is I was trying to execute a command, any command at this point at least. But if this was to be successful, I would run this as root. Okay. But since the student user is not authorized to run commands with sudo, he was not able to do so, and it was logged. So there is a system log that actually recorded this. It said, okay, the student user tried to run a command via sudo that was not authorized to do so. It was recorded so that that admin can come back and check if someone was trying to abuse the system in some way or form. But I can authorize a student to be able to do so. And so I can just go to the root user using the method you just saw. And then I can authorize student to use either all commands or a set of commands as root. Okay. So I can just type, now you know how to use a text editor at this point. So I can just type this. Okay. I can just use a text editor to edit the sudoers file. I'm not going to. I'm not going to go in much detail about this whole file. Okay, that's for some other training, not this one here. But I will go somewhere into the end of the file, somewhere on this section here, somewhere here, and you'll see some entries already added. So if you see a percentage mark and a name, this is a group. So all members of the group. Or you can single out someone. So I just get, I don't know. It doesn't really matter the position. I'm just going to add here. Let me just double check the detail. Yeah. So if you do, let's put it here. I don't care. Here. You see that it says warning changing a read-only file, which is okay, which is true. But since we are using the root user, we are fine. Just ignore for now. Now I'm going to say it's the student user. Okay. It's going to go along with all the examples that you have some examples here. So I'm going to say like the one before, and I will explain what this means in a second. Okay. So this basically is telling me that the student user can run all commands as root. Okay. I could specify a list of commands. So if I scroll down a little bit, you have some other examples. So here you can say that this is not applied. This is commented out with a hashtag, which means that since this is commented out with an hashtag here, okay, it means that it's not being applied. Okay, it's just it's there if you need it in the future, but it's not being used. So this means that if it was used, all members of the users group can run a set of commands. So I can give it a list. Can give it a list of commands to run. Okay, you can do that also, and you also have the option to add the no passable the all. This option is going to allow you to it allows you to run command as root, but you don't have to type in the any password. But in this case, I'm going to do that something like this. I will not supply a list. I will allow all commands. And I will require the password to be typed in. Cool. Now, I just need to save and quit. Go back to my student user and try again. So I will type the password for the student user. And now I'm able to run it successfully because I am now I am allowed to run commands via sudo. And there it is. Now, to check the log, to see the previous failed attempt, I'll just go get root access or use sudo itself. Just pick your poison. Go to the var log directory. And I think you should check the secure log. Okay. Let me just get some space. Cool. So this was our success. Okay. And this was our failure. So user is not allowed to run commands because it's not on the sudoers file. And here he was able to run it successfully because he was on the sudoers file. So both techniques are okay using the SU or using the sudo. Bear in mind the SU, it's more broad. So imagine that you have 50 users and all of those 50 users know the root's password. So if 50 people know and have access to the root's password, we have 50 potential root users, right? So if you have 50 people, all of them that know the root's password, all of them can run this SU command successfully. So if at 5 o'clock in the morning something happens, you will never know who ran the command because the logs will say root did that. And if everybody has the root's password available, then you will never know who actually did that. Via sudo, you will have to authorize specifically a group of users or specific users to use sudo. And every time someone uses sudo, it gets logged. So SU, it's quicker. It doesn't require any previous authorization, but anyone that knows the root's password can become root. So it's kind of harder or almost impossible to narrow down who did what because everybody's root in a way. By using sudo, you have to previously authorize a group of users or a user to do either all commands or some commands, and all the sudo actions get logged. So different ways to get to root with different results and different ways to apply. Again, the same conversation we had before. Experiment, try it out, see which ones suit you, see which ones is better for of the situation. There is not one that fits all situations. There is not the other that fits all situations. You just need to pick the one that suits you and the situation itself to be the correct choice. All right. So right now, that's how you get root or root-like access to a Linux system. Okay. Next, we will learn how to create a user and a group and give passwords to a user. That's kind of the easy part in a way. Okay. So let's go here and I'll just start by checking, for example, okay, we need to understand three files. One is cat passwd, the other one is cat, not cat, I'm sorry. My brain is still jump starting. Let me just some more coffee. Nice. Okay, shadow, and the one is ttc group. So basically, we're going to work with these three files either directly or through some tool. Okay, but these are the three text files that are going to receive the changes we're going to make on the system. Brief description. So the passwd file has the basic user information. The shadow file has the password info. Okay, and the group file has basic group info. Okay, let's just give a quick look at the etc passwd file. So this is going to include for every user something very basic information. Its username here. Then you have an X. Nowadays, an X represents the old location for the user's password. So in the old days, the password will be here. And will be clear text. So let's set up the student's password. It's also student. So it's user student, password student. In the old days, the password will just look at just the word student. Okay, cool. Then you have the IDs of the student. I'm not going to go into much detail about this because this will just make this module much bigger than it is, and I don't want to do that. But this is about its IDs, its user ID and its group ID. You have basically some reserved IDs. If you check the root user, root is 0 and 0 is reserved for root. So user ID 0, it's very special for the root user. So it's reserved. Don't use it. Forget it. That's root. 0 is root. You have user ID 1000. So for 1000 and beyond, bigger than 1000, usually it's our regular users, non-special users, and somewhere in between 0, which is root already taken by root, and 999, it's reserved for special accounts like the ones you are seeing here that I will not go into detail right now, but all these special accounts are used for the system to work. Drivers, services, boot processes, etc. So in simple terms, 0 root, 1 to 999 special accounts, 1000 and beyond normal accounts. That's all I have to do. That's all I have to know for now. It's you should create your regular accounts with ID 1000 and bigger. Okay, that's why student is 1000. Here you have just a text. This is just a description. Don't forget you have the man pages if you forget about this. This is a description. It can be its full name, it can be its address, it can be a social security number, whatever the case. This is a home folder. You already know about this from previous videos. And this is his or her shell. You also know this about this from previous videos. So we have the bash, which is our login shell. I will just show you another one. I will not go into detail about this. You have this one here, which is a no login shell. The no login shell makes sure that this user cannot log into any interactive shell. So it will not be able to run commands directly. So this is reserved for system accounts, drivers that are, so system services, for example, need to have an account to be able to start. But since they are services, they should not be able to run commands directly into a shell, only through its service account. So that's why some services have the login shell applied. Okay. But for now, we are going to use the bash for most of our examples. That's good enough for us for now. So let's say I want to create a user called training. Now training is stupid and basic. Let's create a user called Alice, for example. So, I'm sorry. Let me just check all three files. So the shadow file has details about the user's password. So basically you see here the user, its hashed password and the password policies, like when you have to change a password, when was the last password change, and all of that information. And then you have the group. Okay. The group will have your groups. Okay. So let's say, but don't be scared, because even a single user will have a group. Okay. Even a single user will have a group. Like, for example, student has his own group. Okay. So let's start by creating a new user. I could create a new user by manually changing these files. I will not do this in this video, but if you want me to do that in a separate video, just let me know in the comments below. And don't forget to like and subscribe, it really helps. But I will use three tools for this. I'm going to use the user, well, more than three, so I'll just use them and get on with it. So let's create a user Alice. So I will do the command user add Alice. That's all done. So we have the user add and the add user. Okay, this will depend on the Linux distribution you are using. Since you are using a Red Hat distribution, user add and add user basically will do the same thing. There is no difference between one and the other. But if you are using a non-RHEL system, like for example Ubuntu, Debian, just make sure you check your man pages, because in some Linuxes, Debian based especially, user add and add user will do different things. In RHEL, in Red Hat, user add and add user are the same thing. But if you are using a non-RHEL system, you should check your documentation, because user add and the add user may be running, may do different things. So make sure to check the documentation. In RHEL, they do the same thing. You can do the same things with each one. I gave Alice the capital A. It was just I should not do that, because user accounts are case sensitive. So I will just reverse this, and I can show how. So I'm going to use the user del, and since I forget, I will just do the -R. So -R Alice. So this is going to, the -R will completely delete all traces of Alice, and I will recreate this, because I don't use the capital A. It's just muscle memory. Okay. By doing this, I can then go check the basic file. As you can see here, I can see Alice was created. The user ID was auto assigned, which is fine, and everything else was auto assigned. So all of this the system has defaults to assign this to a user, and I'm going to use it. However, if you check the user adds -help, for example, you will see that there are many customizations you can apply. I will not dive into this right now, but all the system's defaults for now are good for me. The ID is the one above student. That's fine. A home folder, it's this one, which is fine. And the login shell is the bash again, which is fine. The only thing I want to add is its description. Okay. Which has none. To add a description, I could just VI directly to the file, and that's fine. Or I can do the user mod command using the -C, which is a comment. So if I go back, if I just type the -help, if I look here, you see the comment here. So I can just do user mod, which is modify, comment. I never remember which one is first. I think first is Alice, then the comment, second admin or something like that. Okay, it's the other way around. Okay, cool. If I cat again, you'll see the second admin and it's all good. Okay. It looks pretty nice, pretty spiffy. I could VI to the file directly and do the changes myself and save the file, but user mod also does this, and it's also fine. Cool. We have created Alice, but she does not have a password yet, even though she does have a shadow entry. Okay. But as you can see here, it's kind of marked saying that password not assigned, which means that, yeah, that's it. Password is not assigned here. So there is no password. That's what the double exclamation mark means. I can, as root, I can become Alice at this point. That's fine. Okay. But if Alice tries to log into the system, she will not be able to do so because she does not have a password assigned to her. So to give her a password, you know how this works. It's a passability command. I am root, so I can give her a temporary password. And since I'm the root user, I can give Alice any password I want. If this was Alice trying to assign herself a password, she will just have to comply with the security policies in terms of password size, complexity, etc. But since this is the root user doing so, I can give it any password. So I'll give it a password of Alice. I will get the warning saying the password does not comply with the security policies, which is true. But it will get assigned anyways. If I go to the shadow, Alice now has a hashed password, and now I can say to her, listen, Alice, you can log into the system. Your password is Alice, and you can just change your password to something else. Of course, Alice being a regular user, she will never assign a new password because that's how users do. So I need to force Alice to change her password the first time she logs in. How can I do that? I can use a command called change. Again, this command does a lot of stuff on the system about password policies, but the one I want to show you, it's this one, -d, which says here, if you use 0, she's forced to change her password on next login. And that's exactly what you want to do here. But bear in mind that the change command allows us to change lots of things about users' passwords. I can make this change. I can expire a password. I can say the passwords need to be changed at a specific date or at a specific rotation length. So change allows us to tamper with password policies on the shadow file. But in this case, I will do just to change -d0 Alice. If I now do the -l Alice, L means list. I'm sorry, not minus. L means list, and it says passwords must be changed. So the next time Alice logs in, I will tell Alice, listen, your password is Alice, but the next time you log in, you have to choose your own password, and you have to comply the company policies, length, complexity, etc. of the password. And then you have the password. Cool. Let's finish this off by creating a group and put Alice within the group. To create a group, I could just VI directly the file, and that will be nice. But I will just use the group add command. And I would create sec admins. So secondary admins. So if I check the TC group file, you'll see that there we go. We have here the sec admins file, group created with an automatic ID assigned, which is perfectly fine. Now I just need to put Alice inside it. So I could I'll just show you. I will not save, but I will show you. I could just do something like this. Search the group and add Alice there. That will just be fine. I don't want to do that. I'm going to use the user mod command again. And I do the AG. AG means appends to group, which means that Alice will still belong to all other groups, but she will belong to this one too. If I don't use the A, she will just leave all other groups and not belongs only to this one. So Alice sec admins. Okay, it's the way around. Usual stuff, right? You know this by now. Admins ls. Cool. If I cat back the group, the file, there we go. She belongs to the group now. Okay. If I do id ls, you will confirm that. So ls, it's ls. Her main group, it's always ls. Her secondary groups, there we go. So a user always belongs to its own group. I will explain this in a later video. But she belongs to her own group, and now she belongs also to the secondary admin group. That's pretty cool. Now you know how to, well, let me just go to my main camera here. Let's go here. Now, okay, now you know how to use su and sudo to become root user or authorize non-root users to run or use commands as root. You know how to create users and groups, give users passwords, and how to define password policies using the change command. So this video, it's already 35 minutes long, which is, well, my max goal for videos is 40 minutes. I don't want to go over that, so that's fine. Let me know in the comments below if you have any questions. Like and subscribe, it will help the channel to grow and to get these videos to the people. I will just go to Fit to Black, and like and subscribe, it will help, and I'll see you in the next one. Cheers, guys. We need to go through a couple of concepts here just to make sure that everything goes according to plan. So we need to just review a couple of concepts, but strap up, because this one is going to be a longer one. You need to discuss some things before we actually get your hands dirty. So let's dive into some concepts, and we should be good to go for all the rest. So do not forget, our mindset for this chapter is file permissions, folder permissions, and all of that good stuff. There are two main things to cover about permissions. We have standard file permissions, and we have access control lists. Access control lists I will cover when I record the RH124 content for that course. So stay tuned, like and subscribe for that. But for now, let's discuss some theoretical concepts around permissions. Let's dive right through it. I'm going to discuss with you guys a concept called, it can be very deep. I mean, any concept can get very, very deep, but this concept is called the inode. Okay, this is going to be a very superficial inode thingy right now, just enough so that we can understand enough so it makes sense when we discuss the actual file permissions. Okay, so what is the inode? Any file system has this, like Linux or any other. So the inode kind of have some file properties. Okay. So file or folder. When I say file, folder also applies right here. Okay. So the inode has some properties about a file or folder. And for example, I will give you some examples. This is very generic. Okay, not really specific, not a deep dive around inodes. It has its name. Okay, like file name. Okay, it has these attributes. Like, for example, it's mutable, non-mutable. I will not cover attributes right here, but it are also some file properties you can actually discuss. You can have other things about the file, and in the end, you have also the file permissions, which is what brings us here. So file permissions are also embedded in some way or other on the inode or in the inode. So the inode has the kind of the profile properties, our folder properties. I'm not discussing the full gamut here, but some of them, which will include also the file permissions. Okay, so the inode, we have discussed inodes when you discuss hard links and soft links. Just check that chapter and you can see a little bit more about that. But for now, you kind of know what an inode is if you were checking all the series. If you don't, now you know. It's all file systems have an inode or multiple inodes, and that includes the file properties, attributes, and all of that good stuff. You will understand in a second how this applies or why this applies to this subject, which is file permissions. So you have inodes. So the inodes have all of this good stuff,
and this is where you can find all those properties. So also the permissions. So which means the following, something to be aware of. So we'll come back to the inodes in a second, okay? But when we talk about folders, and this is kind of important, folder-wise, and we'll come back to this in a few seconds or minutes after discuss a couple of other things. So, for example, let's say you have a folder. Let's put here a rough representation of a folder. So you have a folder. So the folder, let's say, will have its own permissions, perms, and we'll discuss permissions in something more specific in a second. But don't just get this, just bear this in mind. Folder permissions will also have an influence on the files the folder contains. Okay, so folder permissions will also have an influence on the files the folder contains. So this is going to come into play in a few seconds or minutes when we discuss some of the stuff. But don't forget that permissions on the folder will have an influence on the file it contains. Okay, with this in mind, let's check out some other piece of information. So I'm here back on my Rocky servers, and I'm going to focus here for a second on Rocky 1 or Rocky 2. It doesn't make any difference if it's Rocky 1 or Rocky 2. But let's focus on Rocky 1. Let's check our current location. So we're on a root folder, which is fine. And you have here a random file. That's fine. Let's just create a random folder. mkdir folder. Okay, and inside that, let's just create some files. So if you remember correctly, the touch utility allows us to create empty files or allows us to change the timestamp of a file. So let's create touch sample file, sample file.txt. Okay, and let's also create a folder, mkdir sample folder.txt. Okay, so we are good to go here. Cool. Why did I give the sample folder txt a txt extension? I don't know. It's still 6 a.m. so I'm kind of brain rot right now. So let's just remove that just to make sure that I'm not looking this in the wrong way. And let's create this as a sample folder. Cool. Now this is enough for the full discussion for now, at least. So if I do a long list here, you can see that these files have properties around here and properties around here. And this is what I'm going to take a sample image of, and I'm going to work with that. So let's sample this part of our information. So let's put it somewhere here. Let me find this on my document. I pasted it, and it usually pastes this on to random location. That makes no sense. So bear with me a second while I pull this in somewhere else. This also pastes in something really weird. Cool. Now we have it here, which is awesome. Now let's go back to our notes, and we have here the sample of the file system. So now we have here some characters that will represent stuff, and this is what we're going to interpret. So right here on this column here, blacks, it's fine. In this column here, we have a dash and we have a D. So dash means file, regular file, regular text file, regular executable file, and D means directory. Okay, which I think most of you guys already kind of got the gist of it. But these are not the only two. You will see, for example, you will see B for block. Block device usually means storage, hard drives, SSDs, whatever. We'll cover that in a later chapter. This is a block device. Then we have also C, which is character device. Character. I'm sorry about my handwriting. It's too late to fix. Character device is something special, like the devnull and other special devices that we have in the system, like the random, the random. Don't worry too much about all of this, because this is something we'll discuss while we go. And something we also know, which is the L, which represents a soft link. Okay, so file, directory, block, character device, and link. So that first character tries to identify to us what this file is all about. Okay, then we have, let's change colors for a second, all of this block of information. So all of this block of information represents the permissions, which is the thing we're going to discuss here, which are the permissions, well, the standard file permissions. Here we have this is a full stop, and at this time, this is actually a full stop. This means absolutely nothing special. It's just kind of at the time the way they managed to represent, okay, all the file permissions end here. Okay, so there is nothing else to see. You are at the end of the file permission set. There's no more to see. It ends here. As we progress on our training courses, and as we, especially when we reach the RH124 training, you will see that this represents some other stuff, or can represent some other stuff. But we will, for now, stick with this. So this is the kind of the dots. This is the end of what is there to see in this type of context. There's nothing else to see. Here we have we have discussed this. These are the hard links. And then we have here two columns which represent, this is the group owner. I'm sorry, not a group, sorry. The user owner and the group owner, okay? So this means that root is the user that owns the file. Root is the group that owns the file, okay? So root is the user that owns the file, and root is the group that owns the file. So as you guys already know at this point, we have discussed user creation and group creation. When you create a user, he is always part of his own group, okay? And the reason being is that when you create a new file or folder, then that file or folder belongs to some kind of group. It's not kind of homeless in that matter. So if you go back here, this represents three groups of permissions. This is the permissions for the user. The second one is the permissions for the group, okay? And the other one is the permissions for the all the others, okay? So that's why many times you see this represented as UGO, okay? The user permissions, the group permissions, and all the other permissions. So this is kind of how Linux file system permissions are set for the most part. The other ones can be as access control lists. We will discuss access control lists later on, and also we will have something called the thing called SA Linux. We have not discussed yet SA Linux, but these are the three main things that can influence file access. The permissions, which we are discussing right now. ACLs we will discuss later, and Linux and SA Linux that we will also discuss later on. So all of these three can influence file access permissions amongst other things, but these are the main things we should consider first. Standard permissions, which are the ones we're discussing right now. Standard permissions, access control lists, and SA Linux permissions are the three that can actually influence how a file is being accessed or can be accessed by a specific user or group. Pretty great. So pause our video here if you want to kind of check it out. I'm sure that most of you guys are watching this at 2x speed, which is it's also what I do, and some people are watching in half speed. That's all fun. We are all different, and yet we are also good people. So let's discuss what those letters mean. So we have three main letters. Oops, sorry. We have three main letters, which are the R, the W. Oops, my handwriting is horrible. Always has been. RWX, and this means read. Come on, I can do better. Let me try this again. So read, write, and execute. Okay? So read, write, execute. Even though they look a little bit kind of what you see is what you get, let's discuss this in terms of if it's a file or if it's a folder. Okay? This will represent different stuff. Okay, file if it's a file or if it's a folder. So I will give you three examples. An example of reading your file is, for example, doing the cat, doing the more, or for example, doing the quit without saving. Okay? That's kind of using VI or VIM to access the file and exiting without saving any part topic information. So that's right. Read. Write, it's to, well, for example, going back to VI, doing the write quit, so saving the information to the file, doing some redirection. For example, it's also an example of writing to that file. Now let me just, I will just pull this a little bit up so you can see behind my camera. So what the other one is execute. So execute, can you see here? You can see here. Execute means something like it's a binary file that you can set it as an executable, or it's something that is converted to a script. We will discuss scripts on the RH124 course, so like and subscribe to get notified about that. So we have a text file that is converted to a script. It's also resets the execute permission. Now, if you focus in a folder, read a folder, for example, it's to ls the folder. Pretty simple. Write to the folder is to create the file within the folder or change its contents. So if I create a file within the folder, okay, it's right into that folder. Okay, so I am creating a new file within that folder. And remember where we started when we discussed the folders and the inodes. You'll see that this is going to come into play in a second. Then you have the execute permission. The execute permission can be the kind of the weirdest one of all three when applied to the context of a folder. But the execute permissions of a folder is the capability of doing the CD into the folder. Okay, so I can only CD to a folder if I have the execute permission, which is kind of weird, but it's the truth. So to read a folder is to ls its contents. To write to a folder is to create a file within that folder. X is to CD into the folder. Usually say CD into the folder. It's not actually very precise or correct, but it's not that bad actually. So, which means that in some sort of weird combinations, we may be able to CD into the folder if you have the execute permissions, but we cannot ls if we do not have the right permissions. Okay, so this can happen. So I can CD into the folder, but I cannot list its contents, which is kind of weird, but it can happen. So I can ls the file contents, but I cannot CD into that, or the other way around. Or I can copy files to that folder with the absolute path name. I can put files there, but I am unable to confirm the file is there because I cannot do the ls and I cannot do the execute. Okay, so these things can actually happen if a specific set of permissions actually are applied to a folder. See where I started, so this makes a little bit more sense. So the folders inode has some properties, the file inode has other properties, and the folder inode can actually be very, very powerful. So these are the kind of the permissions you can expect: read, write, and execute for a file, read, write, and execute for a folder. Keep this in mind, because this can mean something like this can happen. For example, let's say the file, this is kind of, let's call it Bob. Okay, this folder belongs to the Bob group and belongs to the Bob user. So Bob is the owner of the folder as a user, and the owner of the folder as a group. So Bob is kind of the group, the set permission set for the folder. Okay, and let's say that Bob, the folder permissions are RWX, which means let's put just not so good here. So let's say the user has full permissions, the group has full permissions, and the others have read permission. Okay, so don't forget this is Bob, and the others have only read. So nothing special here, right? So let's also say that here we have a file called file.txt. Okay, and this file.txt is owned by Alice. Okay, and the permissions are full permissions to Alice. I'm sorry, let's try this again. Full permissions to Alice, and the others have only read, which is also very common. So Bob has full permissions on the folder, Alice has full permissions on the file. All the others have only read. And looking at this, you may believe that, well, before I give you the answer, give yourself a couple of seconds, and the question is, what are the permissions, what are the Bob's permissions over this file? Okay, my question is, what can Bob do with this file? Give yourself a couple of seconds. I will not cut this video out in any way or form. You are watching this as it is. So if I do any mistakes, you will see them. Are you thinking about this? So what are the full Bob's permissions? Okay. If you feel that you need it, you can have a coffee. So give yourself a couple of seconds to think about this. So what you think, what are the full permissions you think Bob has over this? So if you wish, take yourself a coffee break and have a thought about this. So yeah, Bob has full permissions on the files, even though it has, here it looks as if I don't forget, I can do an example when you just jump into the console next. If I forget, just comment down below and then remind me, and I can do a separate video about that, even if it's a short video. So even though the file itself, he has only reads to the others, even though the other file has only reads to the others, since Bob has full access and full power over the folder, he will also can make forced saves on the files that are within the folder. So even though Bob apparently only has the other permission, which is fine, I mean, it's okay. Even though Bob only has write permissions effectively, since he has full power over the folder, he can force himself over the files and also other folders within the folder. So Bob has power over the top hierarchy of all this. He can force himself throughout all the files within that folder. And that's one of the reasons why the root user can actually force saves everywhere on the file system. That's because, root has permissions over the root folder, so he can force himself throughout all the file system. So if a user has full permissions over the top folder, he can force himself on the corresponding files and folders within that folder. There are some consequences to that, but he can. There is one way to avoid that, which is a special permissions called the sticky bit. We'll discuss that in a second. I'll tell you this chapter will be a long one. So if you set the sticky bit, properties or the sticky bit value on the folder, which is the sticky bit applies to folders. If you apply the sticky bit to the folder, then what it represents is that even if you have full access to a folder or its contents, you can only delete what is already yours. We'll discuss this later on. So if you want to avoid that Bob does this, you should set the sticky bit and a couple of other steps, but the sticky bit should be the one you should be looking for. Okay? So let's jump into the terminal. Okay, and let's start to get our hands a little bit dirty, because if you understood these previous concepts, feel free to rewind. Feel free to come back to the previous part of the video to check all the details out. All of this that comes after that should be, I won't not say easy, because life is never easy to anyone, but it could be a little bit more better for you to absorb that information from this point on. Okay, so let's go back to our files. Let's just clear this and do a long list. So there we go. We have our folder and now have our file. If I list the long listing, you'll see all these properties, read, write, and all of that good stuff we just have discussed. Now, let's imagine you want to change, for example, the owner. Okay, so right now the owner is root, the group owner is root. Let's say you want to change this for some reason, and you are entitled to. So you can do this in two different ways, at least two different ways. Don't forget that there is always more way than one to do the same thing. I will not specify all of the ways. I mean, that's pretty normal, but I will show you two. So you can do two commands. One is called the change owner. Okay, so let's say I want to change the owner of the file. I forget which users I have here available, so I work with so many machines, I forget. So let's check the possibility file. So, okay, I have student, I have Alice, and I have Bob. Okay, so let's go here again. So let's do the change owner, and let's say I want to change the sample file. Oh, of course, before that it's the owner, the new one. Let's say Bob sample file. Okay, There we go. Now, if I go back, now Bob is the owner. So I did it with the change owner. If I want to change the group, I can do the change group. And I say Bob can sell. Let's check the groups. Let's check the groups also. DC group. So let's call sec admins. That's fine. So let's use this one. So let's do change group. We just paste or type the name and sample file. There we go. So I have made by using these two commands, I can this changes the owner of the file. This changes the group of the file. Pretty simple, nothing too complicated. It's pretty straightforward if you ask me. So going back here. Now, if you want to be more pro, you can use only the change owner command. Okay, if you want to be a little bit more pro, you can do the change owner command to do both. So can do something. Let's say I want to put it back to root. So I can do root column root sample file. Okay, this changed both at one sitting. Or you can do column and the other guy, which is sec, I forget, sec admins. So I'm hitting the tab key to complete to get some hints. This changed on the group. Okay. So if you use a change owner, you can use the user column group technique. And you can change one, the other, or both at one sitting, or you can use the change owner and change group commands separately to change both. So both of them are correct. Both of them are just fine. You can just choose one or the other, and it's all fine and dandy. So right now, root is the user that owns the file, and secadmins is the group that owns the file, which is fine by me so far. Now let's change these guys there. The effective standard permissions. Let's change these two right here, which is fine. So here I have two options. I will start by I call it the alphanumeric. It's not correct, but alphanumeric. Some of you guys are just cringing right now, but it's fine. Just comment down below if you are cringing or not. But he's using the actual letters. So let's do the command to do this is the change owner command. Okay, the change owner command will allow us to change the own. I'm sorry, I'm dumb. chmod, that's the right one. So we will use the change mode command to change permissions. Okay, and then you can do something like, for example, let's say I want to give the root user the execute permissions. I want to give root the execute. What I do is user, give it execute, and the file name. I'm using a file as an example, but you can do it on a folder. It's the same thing. These commands I have been showing you guys. It's the same thing for a folder. It's exactly the same thing. Okay. So there you go. The root user now has execute. Not too bad. If you want to give it out, if you want to remove it, you just need to remove it. There we go. The first one gave the permissions. The second one actually removed the permissions, and it's all fine and great. Now, if you want to do something for the group, you can do like this. If you want to do for the others, you can do like this. If you want to give it to multiple people, you can do user group. You can do user others. You can remove, and you get the idea. It's very visual. It's simple. It's kind of what you see is what you get, and you're good to go. The other one that you probably saw people doing is the chmod and doing some crazy numbers. That's the binary method. Let me explain this, how it works in a second. So the binary method. So the binary method, it's as follows. So we need to kind of understand a little bit of how binary works. I will not give you a throughout explanation of how binary works, but I will give you the simplest part, the enough for you to understand this. So let's represent here 3 bits. Let's put 1, 2, 3 bits. Why 3? Because we have read, write, and execute, so that's enough for our intents and purposes. So we have 3 bits, and each bit represents the kind of permission, read, write, and execute, which is fine here. Cool. Now what we do here is just to activate the bits we want. Well, I just said it the other way around. Deactivate the bits we don't want and activate the bits we do want. And remember, and you need also to remember, it's decimal value. It's a decimal value. So let's say we have the 3 bits, and this is worth 1. This is worth 2. This is worth 4. So it's just a matter of doing combinations of this. So let's say I want to do read nothing, nothing. I will activate this bit. I will deactivate the other 2, which means it's 4 plus 0 plus 0, which is 6. Wow, I'm good at. I'm really bad. 4, of course. Jesus, man. Okay. So let's say I want to do write WX, activate, do not deactivate. And this is going to be 4 plus 2 plus 0. Now we have a 6. Let's say I want to do 111. This is 4 plus 2 plus 1, which equals 7. And I think that's all of them, except of course the activate nothing, which is obviously nothing. So this is how it's done. Let's go back to the console now, so we can actually see it. So I can do something like, let's say the end result is read write nothing, read write nothing, read nothing, nothing. This is what I want to obtain. So I can do ch mode. So if it's 664, and the file or folder, and result. Okay. Let's say the result that I want is like this. So then it's going to be 644. There we go. Let's say I want to make this like this. So which means that the others will just get the 0. See, I think you guys get the idea. You probably have seen also a 4th number, like 2640, 2644, whatever the case. That's extra number on the left hand side of the permission set. Represents a special kind of permissions, but we will discuss them in a second. Okay, they are called the set user ID, set group ID, and sticky bit permissions. We will discuss them in a second, and right after this we will discuss them. And that's why we will probably see a 4th permission number around on the left hand side. You don't usually see it, but you may see it. But you'll understand what that means in a few moments. Take a breather. Take a breather. Do you have any questions? Ask them down below. Feel free to do so, and I am happy to oblige. All right, let's carry on. So let's go right there. Let's discuss the 3 special permissions. They are called the sticky bits. I can do this in the PDF. It's kind of. Let's go here. Cool. Now let's discuss 3 permissions. One is called the set user ID. The other one is set group ID. And the other one is the sticky bits. Okay. The one that it's kind of more harder to digest. The one that it's a little bit harder to digest. It's the first one. Because the other ones are just a little bit of a consequence of the first one. Which makes it a little bit... make them a little bit easier to digest. So let's discuss the set user ID first. Okay? So listen to me and rewind this if you have to understand this fully. So basically set user ID, it's something that sets a file, okay? File permission, this is not a folder permission. If you can apply this to a folder, but will do absolutely nothing. So set user ID means when a user executes this file, the file will execute with the rights of the owner and not with the rights of who executed it. Example, Let's say I am the student user. If I execute this file with this permission set, if student executes this file, the file will be executed as its owner and not as student. Again, let's say that this file belongs to the root user. And this applies, once again, this only applies to files that are executable, binary executable files. If the student executes if the student executes this file will be executed as a root and not as the student. Okay, so this file is owned by the root, and student executes the file. So which means that if student executes this file is going to be executed as root, which is the owner, and not as student, that is who executed this file. This applies to binary files. So this file will be executed as its owner and not as the one who executed it. Sounds weird? Yeah, it sounds weird as F, but let me give you an example. So let's think about some stuff we already know. So we know, let's consider this. So you have a file that contains the user's passwords. That file is DTC shadow. Okay, DTC shadow file contains everybody's password. Cool, that's something we already know. Let's also think about something like this. Who can change the password? For example, is student able to change his own password? Is the student user able to change his own password? Yes, he is. Everybody is entitled to change their own password. But if you check the permissions of the shadow file, you'll see that the shadow file, you know how to read permissions at this point. You see that the shadow file is completely inaccessible by everyone. Okay? It seems that nobody can change it, but the only one that can change the contents of this file is the root user. Okay? So the root user is the only one who is entitled to change this file. Even though it doesn't look like it based on what you see there, which makes sense for you guys right now, there is a kernel tweak that they have applied that says user can't change. The root can change. Only the root can change. Even though it's not specifically explicit on the file system, the root can change. The root can change this file. Okay? But you also know that any user can change its password. For example, the student user can't change his password. So if only the root can change the contents of the shadow file, how can the regular user change his own password? Let's think about something else also. What is the utility to use to change the password? So let's say the student user wants to change his own password. What is the utility he uses? He uses the passwd, right? That's right. So I am not student right now, but I could, as a student user, I could just change my own password. So let's check the passwd utility. Okay. And let's check its properties. Cool. This is the executable. It is executables in it because you see a bunch of access. But you also see here an S. And the S actually means that permission that you just discussed. This is the set user ID. So the S on that position means the set user ID is set. Okay? That is pretty good. So this is the set user ID permission is actually set. Okay? Which is pretty nice. Now, since this permission is set, okay, since this permission is actually set, okay, means that this permission actually applies, which means a user that executes this file, okay, the file is going to be executed as the root, because the root is the owner, not as the user that ran the file. So since this permission is set, means that the user will execute this as the owner and not as the user. So if student executes this is going to be executed as root and not as student. That's why the student can change his own password, or Bob or Alice or whatever the case. So Since this file is executable, because this applies only to executables, since this file is set as an executable, okay, and has this bit set, it means that he can actually change his file's permission. Yeah, I'm sorry. He can execute as root. So student executes this as root, not as student. That's why the user student can change his own password. I know this sounds confusing, but rewind this a couple of times and listen to this a few different times so you can actually listen to this multiple times. So the user executes as root. This file will be executed as root and not as student. If you remove this permission, then nobody can change this password because only root can change the contents of the shadow file. Okay? You may be asking right now, how do I do that? So I can do chmod user plus s and the executable. Now if I see this, now it's kind of a different color. The s is missing, it's not there, which means that now the set user ID property or permission is not set, which means that now only root can change passwords. Nobody can change their own password. And this can be your goal. You don't want people to change their own password. You want people to request root for that. And that's fine. To set this back, you do the u plus s, and this will now put everything back. So this is a good example for the set user ID permission, which says, I will say it one more last time. The set user ID permission says, when this permission is set to a binary executable, this will execute as the owner and not as the one who executed. So if student executes this file, the file is going to be executed as root and not as student. Okay? Rewind this a few times back if you wish to rehear this if you wish. Now the other one, it's a set user ID. I'm sorry, I'm dumb. The group ID. The set group ID, it has only effect on files, not on folders. And I mean, it depends really. If you set this permission on the file, we'll have one result. If you set this on the folder, we'll have another result. That's what I wanted to say. So let's say you set a group ID on the same file here. Let's do this as an example. So let's say you set a group ID, then you will see an S here. I can do it for you guys to see. So I can do, it's the same thing as the previous one. You just do G plus S. And we'll just appear an S here. And this will say similarly to the first one, but with slight changes. If you do this to an executable, now this file will execute as a group that owns the file, not as a group that executed it. So it's kind of the same phrase as the previous one, but applies to the group instead of the user. This is not very commonly used, but it may be. Okay, this is usually used on the folder. And if applied to folders, it says, before I explain, let me show you a folder. Let me see if I have one here, right? Yeah, I have a sample folder. So the folder has these permissions, root, and these permissions here. Okay. So if I create a new file, nothing special happens. This is very predictable. The new file here, it's owned by the user that created the file and the group that created the file. And that's kind of expected, right? Nothing really special here. Now, it's also very common in some situations that the user is the owner of the file, but some other group is the owner. So let's do change group. Let's say the student group is the owner of the folder. So now the student group owns the folder. The user root still is the user owner, but the group owner is some other group. If you create a file now, if you create a file now, you see that nothing really changed. Again, not too surprising. But sometimes you want to make sure that the group that owns the folder, also owns new files. So newly created files should look like the user that created, and the group owner of the folder also owns the files as a group. That's when this permission comes into play. chmod G plus S, the current folder. Okay, if you see an S here, now you can create a new. Okay. Now this means that, see, the file I just created, now the group is also its owner. Okay. Now the user owner is root, but the group owner, it's a group that owns the folder. Okay. Then you can set the group's permissions accordingly. Okay. So that it has some different permissions. So in this case, you can immediately give the group owner also some special permissions of new files created within that folder. So GUID applies to files or folders. If you apply to an executable, it will be executed as the group owner of that file. If you apply to a folder, newly created files on that folder are automatically also owned by that group. This can be useful if you want to have this group to also be some sort of admin of that folder, which can be quite handy. So set 3 special permissions. Set user ID will applies to executables. Set user ID will execute as the owner of the file, not who executed it. Set group ID, it depends if it's applied to executable or to a folder. If the set user ID is applied to an executable, it will execute as the group owner of the file. If applied to a folder, newly created files on that folder will be owned by that group. And the last but not least, we have the sticky bit. This is the one that you understand easily. Sticky bit means that even if a user has write permissions to a folder, he is not able to delete files unless he's the owner of the one who created it. Okay, so sticky bit, again, sticky bit means even if you have write permissions to a folder, you will be only able to delete files that you created. And give yourself a second and think about this. Do you know or remember any files, if you remember any folders on the system, on any Linux, that allows anybody to write to there? Okay? But you cannot delete every file. So in theory, if you have the right permission to a folder, in theory, if you have the right permission to a folder, you can also delete the files. Right? But can you remember any folders on the system that everybody can write to there? But they can, well, this is the first part of the question. So do you remember any folders that are on any Linux system that everybody can write there? Anyone? Do you remember an example of that? Think about it for a second. Do you remember any files or folders on any Linux system that everybody can write to there? So we can discuss the sticky bit a little bit further. If you thought about the var temp and the temp folders, you are correct. So the var temp and the temp folders are an example. If I go to the var temp, you'll see that everybody. Oh, wait, where is it? Oh, sorry, I need to put the A to get the current folder. So everybody can write to there, but if you check here, it has a T. T means sticky bit. So everybody can write to the var temp. Anyone on the system can write to the var temp, but I can only delete files that I have created. For example, the student user can write to the var temp folder. The student user can write to the var temp folder. Yes. Okay. So the student user can write to the var temp, but he can only delete the files that he owns, that he created. So even though everybody can write here, they can only delete what they have created, not everybody else's files, which makes total sense. That's the sticky bit. Sticky bit means you can only delete files that you have created or that you own. Okay, so everybody can write to the temp or var temp. This camera. So everybody can write to the temp or var temp, but you can only delete the files or folders you have created within that folder. Okay. So 3 special permissions. Ask down below if you have any questions. Ask down below if you want anything to be more further explained with more examples. or comment at all. Like and subscribe, and also it really helps the channel to grow a little bit more. Cool. Now, last part of this long chapter, I told you that this was going to be a long chapter, are the default permissions. Okay, the default permissions. So let's discuss a little bit more the default permissions. Okay, the default permissions. Okay, what are the default permissions? Are as follows. So we have here, let's go back to our initial folder, which is a little bit more simple. So when I create a file, it immediately has some permissions. So this is not the case. Let me just remove this file because I want to create a fresh one. Touch fresh. So I have just created this file here, and I have created this folder that I haven't touched the permissions. So when a new file or folder are created, new files have this set of permissions, and new folders have this set of permissions. Why? Because the guy who set this up on the file system and who set up this operating system, which is RHEL and all RHEL-based systems, so decided. So let me show a quick thing. You have a thing called the umask. Okay, so the umask has this set of permissions. So let me do first. Let me set the umask to nothing. Okay. Okay. So here I have the umask set to nothing. Okay. Now let's create a new file. Let's call it file fresh 0000. As you can see now, it has a different permission set from the fresh file I just created a few seconds ago. Let's do the same to the folder. Make clear fresh 0000. Of course, I cannot create a folder with the same file name. Cool. Now I have a freshly created file and a freshly created folder. Okay? All good here. So, but the permissions are different from the ones I created a few seconds ago. So these ones had this permission, and these ones have these permissions. Why? Because when these were created, they had some permissions taken back from them, because the umask has done that for us. The umask has removed permission. I'm sorry for the noise. The umask has removed permissions from when the umask was set. If you check the default one, didn't I show you the starting point? I think we did, didn't we? Where is it? Where is my previous umask command? Didn't I do the umask before I reset it? I didn't show you guys. Because I'm stupid. But the default umask is 0022. Man, didn't I show you guys the umask before the change? Oh, it's there. I'm blind. Okay, there it is. So this is the umask before the change. This is the umask after the change. Okay. So what does this mean? Well, in order to understand what this means, let's kind of go back a little bit to these notes. So here you have the binary method to set permissions. If you look here, which permission is worth 2? It's this one. It's the right permission. The right permission is worth 2. Okay? So if I go back here, since this permission is worth 2, this means that I'm subtracting the right permission from the original permissions. So this is kind of the before the change. Okay, this is after the change. So before the change, the right permission was there. Okay, so if I was using no umask, if the umask was doing nothing, this is what I would get on a file. This is what I will get on the folder. So if the umask was doing nothing, these are the de facto default permissions on the file and on the folder. So again, if the umask was doing nothing, these are the default permission, de facto default for a file. These are the de facto default for a folder. Okay, but the umask, the default umask is 0022. which means it's subtracting the right and subtracting the right here. This is kind of the others, group, owner, and special permissions. Specials are set user ID, set user ID, set user ID, set group ID, sticky bit. So retract the right from the others, retracts the right from the group. Okay, well, that's why it's retracting the right here and from there. So after the mask is applied, which is applied always, you will subtract the group, the right on the group and the right on the others. Well, the other way around, of course. The right on the others and the right on the group. Okay? That's what the mask is doing. This is the default mask for every user on the system. It's 0022. That means that when I create a file, it's subtracting the right on the others and the right on the group. Since the folders start with a more broad permission, it's still subtracting, but the remainder, it's a little bit more wider because the starting point it's bigger. So the default de facto permissions on the folder are full permissions, but we need to subtract on the others and subtract on the group, and that's why in the end they get these permissions here as the de facto final ones, and these are the de facto final ones for a file. So a umask is kind of subtracting from the de facto ones being for a file this one, the de facto ones being for a folder this one. So we have a bigger set of permissions as the de facto default ones, and this will subtract from those ones from the de facto broader ones. So let's set the default ones back, and let's say you put the 2 here too. So in theory, new files will be read. I also subtracted the right from the user. So the umask allows you to set what are the default permissions, but bear in mind that the de facto ones are these for files and these for folders. So you are subtracting from this. These are the de facto ones. In my file system, some other file systems may differ a little bit, but this is kind of the generic thing to think. That is, these are the de facto starting permissions for a folder. These are the de facto starting permissions for a file. Okay, and then you will subtract from those. Okay, let me just trace back a little bit because I forgot to show you how can you change permissions of set user ID, set group ID, and sticky bit using binary method. It's easy to you can just do the change command for the ch mode, and if you go round about this area here, somewhat here, there we go. So if you see the fourth permission for its group ID to its sticky bit, and I'm sorry. The first one is set user ID for, set group ID for 2, and sticky bit for 1. So if you see 4 permissions, it's like ch mode. Okay, that's got B, X, Y, Z. The B equals set user ID, set group ID, or sticky bit. Okay, so 4, 2, 1. Okay, and that's how you can set also the special permissions using the ch mode method. This was a long one. I know that it was. You really should watch this again as many times as you wish. It's free. You can just rewatch it as many times you want to do so. Thanks for watching. Like and subscribe, it really helps. Ask any questions you may have on the comments below. I'm really happy to reply to any question. And nothing on the next one. Yeah. So chapter 8, monitor and manage Linux processes. Let's go. Nice coffee. So let's jump into the console with no hesitation or delays. So sorry about that. So the idea here then is to monitor and manage Linux processes. Am I typing this right? I think I am. Yeah. So I have a little drip in my nose. You know what I mean? Cool. So let's discuss a few tools here. Of course, I'm not going to go through the full gamut of tools, just a few, but these should be good enough for you to build your own toolkit, like I usually mention. So let's do something like, okay, let's talk about the PS tool, the PS3 tool, the top tool, the LSCPU tool. And I'm forgetting something here. No, these are good enough for us to start. Then I will discuss the kill tool and all the plus and minuses and things around this tool. Okay, so let's start with the PS tool. PS means process snapshot, and like the name implies, it's a process snapshot. Yeah, I said the same thing twice, I know, but it's kind of the truth here. This is a process snapshot, which means that it's going to give you a process list. It's nice, a process list, but in the format of a snapshot. Snapshot meaning that it's going to be an instance in time. So it's not progressively changing as things change. So it just shows you how it is at that time and nothing else, which is quite good, because then you can interact with that output with tools like PS, like grep, AWK, and all of that stuff. So since it's a text output in static to the screen, it will help you. It will allow you to filter out further information. Okay, but if you check the main page for the process snapshot, you will see that the process snapshot utility has lots to be used, and this is true about most tools that you have, or most, maybe all tools we have been discussing here. Always explore your main page to get more details further than the ones I'm giving you right here. So I'm going to give you two recipes, the PS-EF. So the PS-EF allows you to see the process list that will contain the user accounts that spawned that executable, or whatever the case. The process ID. So I bet most of you guys know what a process ID is, but here it goes. So a process ID, it's the ID of the process. Again, as I repeat myself twice, I know, but I will further explain. So the Linux kernel will give every process an ID, and that's how it can differentiate one process from the other, and also helps you to deal with some processes or with all processes. PPID means parent process ID, and by parent means this one spawned that one, and so on and so forth. Okay, so that's how we can and should read stuff like this. So just be careful, because even though the PS utility is present in most Linuxes, which is true, sometimes the columns can be a little bit ordered differently. So in this case, you see PID followed by PPID, but it may be inverted. So be careful, because this may have some influence your further decisions about other tools. So just be careful. Just do quick check. And this is the process ID. This is the parent process ID. So this is allow you to know which one is which. Then some information. It's kind of the process timings, but the most important part is the last one. Let me just give it a little bit, stretch this a little bit, and redo the command, so we can actually see the full extent of that information. So this means that systemd it's kind of our main process in a way, and it is. We will discuss systemd on the next chapter 9. I highly advise you to like and subscribe to get notified about the next video about systemd. But the systemd, it's the main process that manages most processes on this Linux box and most Linux boxes. Then you have other processes, and we're not going to dive into much detail in all of these. But for example, square brackets means a kernel process, and since this machine is doing not much, most of these processes are user processes, normal processes. And let's just ignore the ones that look kind of crazy and kind of nuts. So just let them be, and we should be all fine. I'll be back to the PS in a second. Let me show the PS3 here. Oh, sorry, the second recipe. It's the AUX, okay? So AUX allows you to see similar information, but in this case, you'll have some more visualization or visuals about system resources like memory, CPU, and that kind of stuff. So there is not one that is better than the other. You just need to choose which one you prefer, or you feel like it's the best one for that use case, and just use it. If you think this is neither one or the other is the one you want, just feel free to drop a comment down below, and yeah, I'll be happy to help you out, or explore the main page for your liking. So if I go to the PS tree now, so the PS tree is going to show us the process tree, okay, which makes total sense because it's on the name. So it means that this is the parent, and it shows all the child processes, well, it shows all the parents and all the child. So bless your heart. Like, subscribe, it really helps. So this is going to show us all the parents and all the child, okay? And in like this, you can know which one depends on which. So again, this system is not doing much, so it does not show nothing that much fun. But there we go. You can see all the parents and all the child in all the glory, and you can know how they relate to one another. Very nice, very cool, very demure. Okay, so you can also add the -p here. The -p will allow you to also get the information about the process ID on screen, so you know exactly which one is a parent, which one is a child, and which ones well, are related to another, and a process ID, because we're going to use the process ID soon enough, and like this, it's in our actual face. So go back to my list. Now we have the top utility. Okay, let me just increase the window a little bit more without getting my head in the way. So this is going to show us the running processes, but in a more dynamic fashion. Okay, so the top utility has many. Let me just uncover the subscribe. The top utility has many variations. You have top, X top, K top, Z top, topus. I mean, there are many, but this is the vanilla one, the one that is kind of the starting point for all the others. So you can see basically the same information that is a kind of a mix between the PS AUX versus PS EF. Again, come here, explore. You can hit the H key to get more details, but here are a couple of tips. You can hit the #1 key. If you see here, the #1 key will expand your CPU, because by default it's going to show you kind of a summary rundown of your CPU cores and all of that good stuff. If you hit the #1 key, it's going to expand for all the cores, or all the CPUs plus their cores. I mean, as you can see, this machine is doing not that much. So then you have also the runtime, load average, blah blah blah, all that good stuff. So just below, you will see the things that we saw with the PS, AUX, or EF, but more dynamic. So it's updating every 3 seconds, more or less. You can increase the update speed if you want. You can decrease the update speed if you want. So it's all good and dandy. There we go. And this is dynamically updating, which is different from the PS. It's just a snapshot, and it's more static, which allows us to filter out with other tools. You have here PR and NI. This means priority and niceness. We will discuss priority and niceness on the further down the line chapter when I cover the RH124 course. Then you will discuss these two, so I can subscribe to get more information about those in the further videos. Okay, let's go back to our forward list, and we have the LSCPU. So the LSCPU utility allows us to list CPU properties. Okay, which CPU it is, how many cores, how many CPUs you have, the capabilities, the models, speeds, where it's running, blah 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 blah. So this is a good idea to have in handy, because you can only get some conclusions about the system process if you know the CPU. So if the CPU is 20 years old, then you take your own conclusions. If the CPU is 1 month old, you have different conclusions. So by doing LSCPU, you can then get more background to decide if the system is in good shape or in bad shape. the kill utility and all the sub and its brothers and sisters and cousins. We have the kill, the X kill, the P kill. We have multiple different kill-like utilities, but these are always around the same idea and just with different ways of applying of results. But I'm going to show you the kill because it's kind of the one I use forever, and it's the father or mother, call which one you prefer, of all the others. So if you understand the kill, then all the others will just follow suit. Bless your heart. Cool. So now we have lots of information here that you can deal with. Okay, so let's try to get ourselves a process that we can kill. Okay, so let's get some processes running that I don't need, so I can kill. So one process that I use as a victim in these situations is the sleep process. The sleep will just put the machine at sleep at a specific time frame. So sleep 1000 seconds. Then I'm going to put the upper stamp. This is going to put this process in the background. And if I do PS minus EF, the sleep is there. And if I can even filter out with grep for the word sleep. And I can know that, so this is the one I just ran. This does not count. And this is the sleep process. It's just in the background doing nothing special. Even though the sleep utility looks a little bit useless, it's not. Sometimes when you run scripts, putting the machine to sleep for a few couple of seconds before something happens or during something happening, it can be quite handy for the most part. Cool. Now, let's say I want to get rid of this process, the sleep process. Going back to what we know, this is a process ID of the process. This is a process ID of the parent. I don't want to get rid of the parent because I will just lose my terminal and all that stuff, most likely. So I just want to get rid of the sleep process itself. So I just run the kill utility and I just need to specify the process ID. And if I go back, it's gone. Okay, completely gone. So let's launch a new sleep process here. And let's get its process ID. There it is, 2546. So every time we start a process, even though it's the exactly same process as before, most likely it will get a fresh new process ID. Okay, so you need to check and recheck the process list to check the process ID or process IDs of running processes to check its IDs, because the IDs the kernel tends to refresh IDs, tends to not repeat them. So go and check the IDs just to make sure you have the correct one. So in turn, I just killed this without any care in the world, killed and the number, and it's gone. However, when you kill a process, you can kill a process in many different methods. So you can kill a process by using any of these signals here, 1, 2, 64 different signals. I don't know all the signals by the top of my head because I don't have to. You can always check the man page for that. But I can tell you that I know the 1, and I know the 9, and I know the 16. This is the 1 is a restart process. 9 needs kill without care. I mistyped it, but that doesn't matter. And 15, it's clean kill. Okay? So this means that if I issue the signal number 1 to a process, I expect it to restart. If I issue the number 9 process, signal, to a process, I expect it to get out and deal with the consequences later. And if I do a 15, it's a clean the process as cleanly as possible. Clean the process as cleanly as a process can exit. Okay? So we should try the 15 first to see if it has good results. Okay? If the 15 is not enough, then we can just focus on any others that may be a little bit more efficient. So 9, it's very aggressive, but sometimes it has to be done. This is kind of a please get out. 1 is try to restart. This is the expected result. It doesn't mean that it's the accurate result, except for the number 9. The number 9 signal, it's very aggressive and it's just get out and I don't care what happens to you. So if I go back to my PS, searching for the sleep process, there it is. Now, if I want to kill it with the signal, well, if I go back to the previous approach like this would kill it with the signal 15. Okay, that's in a rel box. So if you want to check the main page for your specific Linux, go and check what is the default signal. 15 is usually the default, but go and check if you want to make sure. Then I can issue just I can do like this, -9, and -9 means the number 9 signal, which is the most aggressive, and it's gone. So in this case, the sleep process, it's not very aggressive, not very demanding. So it just kills fine with any signal, but this goes to show that you can actually kill a process with no prejudice. Another way to get the process ID of a process, it's kind of a command called pdoff, and you specify the process name, and it's going to give you the name. So let's compare. So 2554, 2554, so it actually matches. So you can, in this case, the sleep process has one process ID. It's quite safe, but some processes have multiple process IDs because of sub-processes. Be careful with that. Then I just can kill it. Or you can be really fancy. You can do kill the signal. You can open the $, you can then do the command, so pdoff sleep, and hopefully sleep it's gone, because what this did was, I put a 0 instead of a 9, so but it just killed anyways with the 15, but I want to type 9 here. But the main part here is this one, because this is going to expand the following command. So it's going to kill whatever this results. So this gives me that, then it's going to kill, then kill is going to kill that. Again, if you're doing this within this process, be careful, because you may kill processes that you don't want to kill at that time. Thanks for watching. Like and subscribe. This was Chapter 8, Monitoring Linux Processes. Like and subscribe if it helps. Ask any questions in the comments below. I'm happy to reply them. And I'll see you on the next video. And we just go immediately to our terminal. So yeah. So let's kind of switch things around a little bit. That one. So the idea here is to get a new service up and running using the systemd. So in a quick description, in the old days, well, 10 years ago maybe, on RHEL, we used to use a process called init to control services. So that was the main, not to control services. Init was kind of the main process. What do I mean by that? So if I go here to my Rocky 1 and I look for systemd, nowadays you'll see that systemd is kind of the father of all processes. Okay, so our mother, whatever you prefer, it's kind of the genesis of the system, starts with systemd. Okay, but nowadays, the last 10 years or so, we become kind of we cooperate with systemd for that type of stuff, like power on, power off, shut down, start a service, stop a service, enable a service, and all of that. It's different. It's not better. It's not worse. It's just, it is what it is. You just get used to it and carry on with your lives. So what we're going to do here is the iSet principle. This is my principle. This is not something that is widely known, but this is my principle, which is the iSet, which means install, start, enable, and test. Okay, install, start, enable, and test. So these are the 4 steps we're going to fulfill in order to get a new service up and running. And the service you're going to be put up and running is going to be HTTPD, which is a web server. Okay, so I'm going to install this because this is going to be the one I'm going to use for other situations and other chapters. So this will come into handy. So I'm going to install it, start it, enable it, and test it, and make sure that it works. All using newer tools, all using systemd has the process to manage services, Daemons, whatever we're going to call it. So let's start by the install. So package management is going to be a chapter that we're going to discuss further on down the line. But in simple terms, if you want to install the web server, you do DNF install. If you want a quick and dirty recipe, httpd -y. This is going to install the httpd packet, and or packages is going to, the -y means say yes to all prompts, so it makes it a little bit faster to do so. And we should be good to go, not soon enough. And there we go. The install is done. Okay. So no news, good news, no errors. It's good. Life is good. Cool. Now next, going back to our principle, install it's done. Now let's do the start. So start is going to make sure that the service is up and running. So this is now we're going to interact with systemd. So systemctl, systemctl. Okay. Then I can do for starters a status before I do anything else. httpd. So the status is showing us that it's, even though the service it's loaded, exists on the system. Okay. It's not running. So it's inactive. It exists, but it's inactive. If I tell something really that doesn't exist, you see the difference. So this is a service that does not exist. This is one that exists, but it's not started yet. So let's start by starting it. No pun intended. So systemctl start httpd. No news are good news. So if there were any errors to be noted, you would be heavily notified. So no news are good news. So let's do the status again. Now the status showing is that it's running, which is good. So no errors to report. However, if you notice this, it's disabled. Disabled means if I was to reboot the server now, the HTTP server would not start up with the system. So I would reboot it, and the system and the server or service, the HTTP service, will not get up and running automatically. I had to do it by hand with the start command. So in order to enable it, yeah, now it's enabled. It means that by being enabled means that it's going to be automatically started by the reboot. So I'm going to reboot the server. Okay, and when I reboot the server, this service, the HTTPD service, okay, is going to be immediately started with the system. So I'm going to boot the server, and it's going to be automatically booted, which is nice. If you want to be a little bit more fancy, you can do systemctl enable -- now and the service name. This is going to be enabling and starting. So you don't have to do start and enable. You just do in the setting. So this will enable and start the service immediately. Okay, but you can do start and enable as different commands, or just do it like this. Wherever suits your fancy, you just pick up the one you feel more comfortable with. It's fine. So now we did the install. We did the start. We need the enable. Now we need to test it. So if I go here to RHC124 and do the curl, so the curl it's like a text-based web browser, and it's telling me unable to connect, no route to host. So if I go here, back to the status, okay, you will see that it's active and running. And however, RHC1 is telling me that it's unable to connect with the message no route to host. I'm going to give you a few seconds to think about what you think it's may be causing this. So we have installed it, we have started it, it's enabled for the next reboot, but RHC1 tells me that it's unable to connect. I mean, unable to connect, no route to host. Any ideas? Okay. The cause the culprit is a firewall on RHC2. It's now allowing the port 80 to be connected, which is okay, because it's by default it's not allowing, so it's fine, it's expected. So I'm going to do something like firewall cmd -- list, not -- sorry, list. Oh yeah, -- yeah, list all zones. Okay. This is now showing me all the firewall rules. Let's just focus on one zone, which is the public zone, the default one. And I like I am old and oh, there it is. If you want to be a little bit more easy to read, you can do grep public. You can then again do the after 15 lines. This is going to show you the public zone, the public zone and the following 15 lines. So these are all the rules for the default zone, which is the public zone. And I'm going to then add here the service HTTPD, not the D, without the D, HTTP. And I could add the port, the specific port number, TCP port 80, or the service name. Firewall D has kind of a dictionary, so I tell them, and I will show that in a later chapter. So like and subscribe for that. So I'm going to add the service profile, and the service profile it's going to add the correct ports. So let's do the firewall cmd -- add service equals HTTP, and I'm going to say permanent, and I'm going to reload the rules. So if I don't add permanent, it will not be reapplied on the next reboot. But the thing is that permanent rules are not applied on the immediately. So that's why I'm going to say it's permanent for every sequential reboot. And by reloading it, it's applied to the current rules. So if I go here, you'll see that now it's added and I am connecting successfully. Let me see if I connect with the graphical browser. I can. So if you can see here, we are connecting successfully to our Rocky 2. Just to prove to you guys that this is it, I'm going to go to the var www HTML folder. I'm going to create a simple file. Okay, I'm going to say BIM is not installed. I'm going to say something like hi from Rocky 2. And now this should show up a little really poorly, really simple, but you can see that hi from Rocky 2, it's working. So I have proved to you guys how to install a service, start it and enable it. And I have shown you guys also the bare essentials to interact with systemd. So I highly recommend you guys to test the status, the start. You also have the restart option, okay? Also the restart option on systemd, you can do restart the service, stop and start the service, reload the service, check the status, and see how the service it's running and if it is operational or not. We will see this systemd popping up many times throughout the rest of the RH124 course and of course the RH134. Like and subscribe to get notified about all of this good stuff coming up next for following weeks, so you can get acquainted to all the full course. One more time, like and subscribe, it will help, and I'll see you in the next one. Hello and welcome to chapter 10, configure and secure SSH. Okay, so without further ado, let's go to our terminals. Okay, so I have been using SSH throughout most of these chapters because it's more comfortable and easier to me. But I'm pretty sure that most of you guys know what SSH is at this point in time. But anyways, here it goes for the ones who don't. So SSH, it's a remote access protocol. So this allows us to be able to connect to remote machines, so we can configure them remotely in a safely fashion. So SSH is encrypted, which means that it's safe to use, so to connect to remote machines and issue commands accordingly. Of course, we need to be careful and not to be over little zealous. Have some care about the use of SSH, of course, but for the most part, it should be safe enough to use in most situations. Of course, you need to take care, some precautions, not to abuse it, but for the most part, it should be okay to use. Now, how can you access a Linux machine to another Linux machine? Well, it's not that hard. It's actually quite simple. We'll just do SSH and specify afterwards either the IP address or the host name of the remote machine you want to connect to. Okay, so in simple terms, so you just need to go to your destination machine, the one you want to connect to, find out its IP address. I'm going to use a command called IPA. Don't worry too much about this because networking is chapter 11. The next one, like and subscribe to get notified. and I just need to find out the IP address I want to use. And I just need to type in the IP address. The first time I connect, it's going to ask me to save the fingerprint. Fingerprint is like the ID of the machine you want to connect to in your own, like a relationship. Let's say yes. And it's going to ask me the password for the root user that I'm using to connect. And I'm going to type the password, and I am going to fail. I will just type the passwords an extra time more. And it should fail, and just, well, you will just fall back to Rocky 1. Why? Because by default, the root user cannot connect to remote machines. Okay? Again, that's regarding that security thing I discussed. Even though SSH, it's quite safe, it's not 100% safe. So by default, we cannot connect to the root user of the remote machine, because the password then will just go flying by. It should be safe, but in recent times, it's recommended to not to do so. So we just need to get yourselves another user. For example, the student user. I just do SSH to the remote machine. Oops. Let me get the IP address here. Since the different user, I will have to resave the fingerprint, type in the user's password, and now I am successfully logged in. So the root user cannot, by default, I will show how can we just overwrite that, but by default we cannot use the root user to connect to remote machines just because of safe measure. Once I am connected, of course, I can just become the root user using my preferred method, and well, now it's my fault because I just mistyped the password, but that's just 100% my fault. Yeah, you know the password for the root user, big deal. Okay, cool. Now I am connected. I am connected to my remote user. Okay, in this case, I connected through a regular user, and now I am the root user. A-OK, bingo, bango, bosh. Cool. So now I am connected remotely to Rocky 2. No big of a deal. Pretty simple. Pretty nice. So if you are stubborn enough, and you want to allow, okay, let me explain what I'm doing. I'm typing exit, and the exit will just log out from the remote root to the remote student, and I'm still on Rocky 2. If I type exit again, I am back to Rocky 1, and the session was completely closed off. So if you are stubborn enough and you want to allow the root user to connect, you just go to the machine you want to connect to. You edit a file called etc sshd_config. Okay, this is for the configuration of the daemon server. Daemon. Some people call it Daemon, some people call it daemon. You find this section. It doesn't really matter where you put it, but I like to put it here. You just type permit root login. Yes. You save, you restart, and you should be able to allow the root user. I'm going to put this as a comment, but if you want to actually apply this, you save the file. I can show you. Just save it. You do systemctl, restart, sshd, and now the root can connect using the root. I will show you. I don't want to keep this as is, but I will show you anyways. And I'm successful. Okay. I want to go back to where it was. I do prefer it as it was. I'm going to find this. I'm going to comment this out. I will restart it, and now, even though I'm putting the right password, I won't be able to log in because there we go. Root is not allowed to log in again. Cool. Pretty simple. Now, SSH is also used to support protocols that are called SCP for secure copy, and rsync for remote synchronization. So these two protocols are used to copy files throughout the network using SSH to protect, which is nice. But we will discuss rsync and SCP on the RH124 course. So right and click and subscribe to get notified and get information about that. But I'm going to show something else. So right now I'm going back to the student user. Okay, on both machines. So I have the same student user with the same ID on both machines. And what I'm going to do now, I'm going to set up what we call the SSH keys. Okay, and SSH keys are an alternate form of authentication. So instead of putting in the user's password, I'm going to pre-exchange a series of keys. Okay, I'm going to pre-exchange a series of keys, and these keys will allow me to pre-authenticate the user. So why is this useful? Because, for example, there are some automations like Ansible or scripting that if you need to pause and type in the password or put the password on the configuration files, it can be time consuming, it can be less effective, or even less secure. So what we do here is to pre-exchange keys from two machines. So let's say Rocky 1 usually connects to Rocky 2 using the student user. So it means that every time the student user from Rocky 1 connects to the student user of Rocky 2, it will not require the password. It will use the certificate, SSH certificate to do so. The certificate or the key, it's more correct to say key at this point, in this case. So the key can also be protected by a password. So the user's password doesn't have to be the same as protects the key. So we have several levels of security that can be revoked at any single time. So if Rocky 2 suspects that Rocky 1 is abusing the key, Rocky 2 can just delete the key and everything just goes away and you go back to square one. So to use the key, I'm going to generate the key on Rocky 1, then copy the key to Rocky 2, because the keys are usually not present by default. So how do I generate the key on Rocky 1? And and before I forget, this is one way. So this will work from Rocky 1 to Rocky 2. It does not work in reverse unless you repeat the process in reverse. That I will show you. So let's first of all generate the key, SSH, copy ID. I'm sorry, keygen. I'm sorry. I was going one step further. Keygen, and I just need to follow along the prompts. So he's going to ask me where do I want to save my key, and of course I can change the location. That's why he's giving me the prompt. I will not change the location because I'm happy with the default one, because the default one is where everybody's going to look for it. So if by any means I come here 5 months later, I will not remember I did to save this on a different location. It's just bad. So I'm going to save the key on its default location. It's going to ask me for the passphrase. Like I said, I can protect the key with a password that doesn't have to be the same as the user's password. So as you know, the student password is student, which means that the key to the passphrase to protect the key can be something else. Like the user's password is student, the key's passphrase can be potatoes or whatever the case, which is quite nice. I'm going to use it empty because I want to make this as seamless as possible, and only the key will guarantee the authentication. And as you know, this is very reversible. As you can see, it's RSA, so reverse Shamil and Edelman key, with 3000 bits protection. This is kind of the minimum at today's days. And what I want here to use here, it's the public key. And I want to copy this public key to the Rocky 2. So I'm going to use the SSH, copy ID, -I. And I'm going to copy it to the student user. And I'm going to get the IP back because I forget. There we go. Okay, I'm going to type the student user's password one last time. Cool. Now, if I SSH like I did before, you will see that I will not be required to type in any password or anything else because the key actually did all the work for me. So I'm on Rocky 2 successfully using the student user. Okay, but if you noticed, I am on Rocky 2. But if I do the inverse connection from Rocky 2 to Rocky 1, you'll see that now I'm going to be prompted for the password, which is fine. But this is one way. I copied the key from Rocky 1 to Rocky 2. This seamless connection works in this direction. In the reverse direction, it will not work like this. Unless I generate a key on Rocky 1 or unless I generate a key on Rocky 2 and copy it back to RHC1, and they both exchange the keys in a bidirectional fashion, this would work. But by default, it's only one direction. Copy RHC1, copy to RHC2, and that's final. Now, if you are on RHC2 and want to revoke this, you suspect that RHC1 is abusing this. You go to RHC2, to the user that copied the key, which is student. You have a hidden folder called SSH. You have there these files, authorized keys and authorized hosts, or non-hosts. We're going to authorized keys folder file, and this contains the key for RHC1. This is only one. This is only one line. Only one line, but it's truncated because it does not fit in the screen. If multiple hosts have copied keys to this RHC2, for example, RHC1 copy to RHC2, RHC3 copy to RHC2, RHC4 copy to RHC2, you will see all the keys here, and this is just one line. Okay, I will do it, but I will not save it. You just need to go to this file and delete the line that you don't want to keep. So this now I don't want to do this. I don't want to save this. But if you save the file, this will just revoke the key for that specific host, which is called RHC1. Okay. So now RHC1 is not anymore able to use the SSH key in order to connect to RHC2. So this was chapter 10. It's called Configure and Secure SSH for chapter RH124. Like and subscribe, it really helps. Comment down below if you have any questions, and I'll see you in the next one, guys. And welcome back to chapter 11, which is Managed Networking. Let's just roll the intro. That's quite enough. Yep. So let's jump in immediately to our terminals here. If you remember correctly, we have two machines. We have RHC1 and we have RHC2. So which are our dual systems for this RH124, and we are going to go through managed networking, which is all about, well, you guessed it, all about networking configuration. And I'm going to focus right for now on RHC2, just because I have not used it all that much. So let's just give it some use. That's all to it. So in every RHEL system, and this also applies to most Linux systems. This is not a specific RHEL or Red Hat thing. This applies to most Linuxes. So this, you can use this in any, or well, any, it will be a little bit too optimistic, but we can apply this to most Linux systems besides RHEL. This also works. So this is all about networking configuration. I'm not going through IP networking basics like IP addresses, subnet masks, and all of that. I'm not going to go through that on this training, on this chapter, on its training, because I am developing and uploading that specific content to my channel. So like and subscribe to get notified. But I will jump right immediately to the configuration itself. And I like to separate this into two sections. One, it's the one I call the obsolete section. You understand what I mean by this. Obsolete section means commands and ways to do this that are obsolete in a way, which means that they are not recommended in most newer RHEL or Linux systems. So you should use the most current way. But the obsolete way, I like to give it some pointers anyways, because you never know if you're going to go if you're going to cross paths with older systems. So it's nice to have at least some knowledge about that and about that situation of older systems, that because there are more dated Linux systems out there that you might come across. So I'm not going to go through many details, but I'm going to show you a couple of commands, and one of which is the ifconfig command, and the other one is the route command. Okay, maybe when I'm discussing one or the other, I will just diverge a little bit to somewhere else. But for now, let's discuss the ifconfig and route. So ifconfig, it's probably installed, and well, it's not. So since it's an obsolete command, it's usually or often not installed on a RHEL system or any other system. But in order to get it, it's quite easy. You just go to your root login, and you just do dnf install nettools, and this should give you the this will give you the obsolete also at least a set of the obsolete networking tools. Let me just let them to install, and it's quite easy to install. So let me show you the command here. If you don't remember which package to install to get these obsolete commands, well, you can do something like dnf and then provides, and you can give it, for example, the ifconfig tool, and it's going to tell you that after you do this, you will get this tool, and the package to install, it's the nettools package, and then you will have your well, some of the obsolete tools we're going to discuss here, which ifconfig, it's one of them. So I just type ifconfig, and this is similar to the ipconfig on Windows. Well, it's not the same thing, of course, because they are two different systems, but they have a similar output, and in a nutshell, we get the IP address, the subnet mask, the broadcast address, the IPv6 address, and the MAC address, amongst other things, but this is what you get. You also get the information about the LO. LO means loopback, okay? The loopback interface, it's just embedded on the IPv4 and IPv6 protocols, which means that you need the loopback interface to be here. Don't delete it. Don't do much with it unless you know what you're doing, because we need this interface here for normal operation. So let it be. Here we can see the other interface, which is the ENS160, and this is the name of the network card. If you have multiple network cards, you will have multiple names, and these names are derivative or driven from some type of hardware reference, okay? So you will see ENS, you'll see ENO, you'll see USB, you'll see Wi-Fi, etc. So this is a name that is extracted from some sort of a physical characteristic of the network card. The kernel will decide this for you. You don't have to do much. You just need to remember the reference. And usually this means if it's an onboard, a PCI card, a USB card, and it will give you just some funny names. In this case, it's not that hard to read this name, but you may come across with some funny names, longer names. Just don't worry too much about this at this point. Just take a reference of the name. Maybe you have seen things like ETH0, ETH1, etc., which means Ethernet, and the kernel just give it a reference number that you can use. There is much to say more about this, but don't worry too much about this at this point. You will, if you advance yourself in your more deeply into Linux and the kernel and network operations, you will learn more about this with me. So for now, don't worry too much about it. Just remember, you do the ifconfig, you'll get the interface name, you get the loopback. Loopback, just let it be. Don't touch it because you need it. And this one is our specific network card. So we have one network card, which is the ENS160, and that's all you have to do. I'm sorry, all you have to know. Don't forget that the ifconfig, the ifconfig, it's obsolete, which means that in some situations this information will not be good enough, will not be accurate enough, it will not be correct. So if you go to the command page for the ifconfig command, you'll see that this program is obsolete. So you can use it in some situations. For example, in this my virtual machine, it's a very basic virtual machine. It's that it has one network card and not much else, which means that the ifconfig command should work properly for the most part. But avoid it if you want to get completely up to date. But if you are in a system that it's a little bit more dated, you can use the ifconfig, and you should be fine. So avoid using it if you can, because you should use the more current tools. And I'll show you the more current tools, of course. So what you know now is that this is my IP address, this is my subnet mask, and this is my MAC address. If I go to the route command will show me routes, and I'll be not going into much detail about routes. But here we can see the routes we have. I like to use the route -n, because the route -n, it's a little bit more simple in the output. It will show you a little bit more raw information. and this is my default gateway, and this is the gateway's address, and this is what you want to know. Again, the route command, it's still obsolete, as obsolete as the ifconfig command. So trail with care when you are using the route command too. I will show you, of course, the newer commands that do replace the route and the ifconfig command, and you will be completely up to date on those terms. So we have now, what do we know? We know that our IP address is this. Let's take a note. So our IP address is that one. Our net mask is that one, and our gateway is this one. Cool. Now, since you are in a subject of trying to find out information about this specific machine, let's try to find out who is our DNS server. Sure, okay. So in order to find out who our DNS server is, there are many options, but I will just use this command here, and I'll just type some random address. Okay. So the dig utility is not installed because this secondary machine it has a very minimal installation. So it's kind of normal for it to have some missing tools, but you can install it. You can just do dnf install dig. This should be enough. Okay, there is no package called dig, but we know how to work this out. We can use the provides, and which means that the bind utils will provide me for the dig utility, which is great. So let's do dnf install. And you can just then provide the package name. See, you know how to work things out if things occur. There you go. Now you can use the dig utility. The dig utility by itself, it's going to allow us to interact with our DNS server, and it doesn't really matter the results here. It doesn't really matter. What matters is that here is going to specify who is my server that satisfied my request, and that's what we need for now. It's to, okay, this is my server. This is the IP address of my DNS server that satisfied my what I requested. Okay, so that's all we need for now. Our DNS server is this guy here, and we are actually good to go. Now we know our IP address, we know our net mask, we know who is our gateway in our DNS server. Let's do the same thing, but with more current tools, shall we? Okay, so the non-obsolete. Okay, I will recommend using a command called the IP command, and that's the one we're going to discuss first. Then we're going to discuss the nmcli and the nm2a. Okay, so this is going to be, I forgot to put the, okay, these are the three tools we're going to discuss here. Let's discuss the IP tool first. The IP tool allows us well, the IP, it's kind of a very condensate, with many sub-functions, the IP. So if you do the IPA, which means IP address, if you do the IP address command, it will show similar information that we managed to see with the ifconfig command. It's the same thing, just a little bit differently organized and distributed throughout the screen. And you can see the IP address with the net mask, and you can also see the MAC address. Okay, so basically you have the same information that it was extracted by the ifconfig command, but with a more current tool, a non-obsolete tool. And I have here the loopback, and the loopback, there you go. The loopback, it's the one that I wanted to tell you that do not touch it, do not change it unless you know what you're doing. Just let the loopback live on its own corner, and we need it to be happy. We need it to survive. So let the loopbacks be there, and this is the network card we should touch. The information is the same IP, same mask, same everything. So just with a more current tool. We can also do the IP route. Okay, the IP route, you can also see who is our default gateway. So it's the same thing, because all this information is being extracted from the kernel. Okay, so the kernel is the one that is giving us all of this information. So the kernel shows us, the kernel contains the information. Okay, the kernel contains the information. That's where the information is. It's in the kernel. Okay, and that's where this information is being extracted from. So it comes it doesn't matter the tool you use. It comes from the same spot. But in more modern systems, you should use the IP and leave the ifconfig to die. Let it just die peacefully on its own corner. But if you want to use it just for experiment, all the tools, you are of course entitled to it. Okay, so the IP route and IP command showed us the information of, and the dig. It's the dig. Okay, the dig is not obsolete, so you can use it fine. It's still up and running, so you can use the dig all you want. Then you have the NMTUI or NM2I. As you know, TUI means text user interface. Text user interface, and it's on one of these menus here. You know what I mean. So here you can just use the arrow keys to navigate. Okay, and for example, I can do the edit connection. I have the only connection I have. I can edit the connection with the tab key. I can navigate with the tab key. Edit. You can just do. I'm not going to change anything for now. We have all the information that I've just manually inserted, and I can just do whatever I want with all of this. So this is nice if you want to have a little bit more. This is not graphical, but it's a very close approximation of some menu-driven text mode stuff. So it's really nice. I'll come back to it if I have to. Then we have the NMCLI, and the NMCLI, it's a network manager command line interface. This is network manager text user interface. Network manager, it's a service. Okay, it's network manager with a capital N and capital M. Okay, this is the service. This service, now pay attention to this. This service does not provide me the network. This service does not provide me the network. Okay, the network it's being provided by the kernel itself. This service allows us to interact with the kernel to make network changes. Okay, I can stop this service and I still have network. Let me show you. If I ping, for example, some random DNS server on the internet, I'm pinging with success. Now, if I stop it, systemctl stop network manager, it stopped. Let me prove that to you. It's completely stopped. I can then ping still. Okay, so the network manager does not give you the network functionalities. Network manager will just give me some help in order to configure the network. Okay, so network manager, it's a network facilitator. It's a network configuration proxy to make things a little bit easier to me. But the network manager does not provide the network itself. Network itself, it's provided by the kernel. So the kernel gives the network. Network manager allows me to interact with the kernel to make changes if needed. Okay. Good. It's been always like this. Network. It's provided by the kernel itself. It's not provided by some service. It's been always like this. All the tools and services are facilitators to make things a little easier to configure, but it does not give the service itself. It gives just a way to interact with the service in an easier fashion. Okay. Cool. Now let's go back to then do an MCLI. I can, for example, do an MCLI connection. Show. Okay. So I can see that I have two connections, and this in a more up-to-date sense, these connections are profile names. Let me show on RHCSA. Let me go back to let me get the root, and I've mistyped my password, which is fine, I guess. I didn't. Okay, so let's do the NMCLI connection show. Let me just put this a little bit bigger for you guys. Better? Okay. So we have two profiles. We have DNS 760 and the LEO. So these are profile names that by coincidence or with intention, they match the network cards they correspond to. So this corresponds to configurations about this guy, and this corresponds to configurations about that guy. Okay. So the name does not have to correspond with the network card. In this case, it does. just to make things easier. But if you look to this column here, so this profile applies to this network card. This profile will apply to this network card. In this case, the profile name. Why am I so dark? Why is this camera so dark? Interesting. Let me just rotate the light. Wow, something weird is happening with this camera. Never mind, you don't need the camera. You just need to hear me. And this means that this profile, okay, this profile has this. This is the profile name, and this is the device it applies to. So this is the profile name. This is the device it applies to. Okay. Wow, weird. Strange. Is this camera dying on me? Most likely. Oh well, it happens. Well, and this is the profile name. This is the device name. Okay. So the profile name does not have to correspond with the device name. It does not have to, but sometimes it helps in terms of readability. So if I want to create a new profile, for example, I want to create a profile called something else, I can do that, and I'm going to show you guys how it's done. So I'm going to do an MCLI connection. If you don't remember, you can hit the tab key and get some pointers. An MCLI connection add. Okay, and you can then, for example, tab, and I can do the con name. I can give it a name, and I'm going to call it static. Why not? Tab, yes. I can then, of course, there are many options to explore. Okay, I'm just doing this a little, in a really quick fashion. And all of these changes, all of the changes I do with an MCLI, the changes are permanent. Okay, every configuration I apply or do using any other tool like the ifconfig command or the IP command, any change I do with those commands, they are not permanent. Don't forget, I have said this beforehand many times. If you want to make permanent changes, those changes need to go to a file, and the changes I'm doing with this NMCLI, they do go to a file. Okay, they do go to a file. So there you go. Don't forget that any change you want it to be permanent, you need to put it in the file. And an MCLI, it's putting things in a file. I'll show the file in a second. So I have name. I'm going to use the ENS network card because, well, it's the only one I have. Okay. And then you can just go on with the configuration. Let's call IPv4 address. And I forget, let me just remember myself with which is the IP address of this guy. I'm going to recycle my configuration. And again, let me just put a disclaimer out here. Be careful by doing network changes remotely, which is what I'm doing now. I may lose network connectivity by doing this change remotely. So I'm changing the remote server. And if I do some sort of change that will break the network configuration, if I do some sort of change that breaks the network configuration, that means I will lose contact with that server. Okay, so be careful with that. Make sure I have some backup plan, someone sitting down on the remote server console or something, because I'm doing changes remotely, and I have access to the physical server console here. So if there is any problem, I can recover it. But if you are making remote changes to the network, you just be careful that some change may cause the network to break, and this will just disable access to the remote server. So make sure you have a backup plan to recover from some mistake. That being said, avoid making network changes remotely that may break your network connectivity and break your remote access to that specific server. Okay, disclaimer done. Okay, let's give an IP address, and the IP address I'm going to recycle the same IP address, which is fine. Then I can IPv4 gateway, and I can give it the gateway number, which is the other one. Okay, And that's it. I know I'm not configuring the DNS server IP address, but I will do it afterwards, after the fact, so I can show you how it's done. Or I can do IPv4. So all that I'm doing here also applies to IPv6. Okay, it's the same thing. You just do change 4 to 6, and it's the same thing. DNS, I can say it's the 1111. Okay, type. Yeah, I forget the type, which is fine. I can just go somewhere around here, type, and Ethernet. You have Ethernet, you have Wi-Fi, you have bonding, teaming, and there we go. NMCLI, connection show. There's my profile static. In order to enable it, NMCLI, connection up, and there we go. I don't know if I'm going to lose connectivity. I did not lose connectivity because I just reused the same IP address, so you should be fine. And I do the show. There we go. My new profile is now applied to the network card, which is pretty simple to do. I can do an MCLI connection show and check this and check the details like this. And if I go somewhere here, there we go. Have the configurations, my IP, my DNS, my gateways. If I want to do some change, an MCLI connection show. Okay, I can do an MCLI connection modify, for example. I can give it the name, and I can, for example, add an DNS server, IPv4 DNS, and well, not VC5. I can give it the good old 8888. So if I put a plus, I'm adding a DNS server. If I put a minus, I'm removing a DNS server. And if I check the details again, you should be able to see those two added. Pretty straightforward. Now, I said that this is permanent. It's getting written. This is creating files, and the files are here. etc. Network connections. Network manager. And I have here a subfolder called system connections. And you can see that I have two connections that match an MCLI connection show. So I have the static, I have the static, the ENS, and I go static and ENS. So these are the files that correspond to each profile, which means I can do something like this. If I want to create a new profile based on another one, I can just go here, pick one. Okay, let's use this one as a reference. I can just do a copy, and let's call this static 2. Then I can edit this guy here. Okay, and I can use the changes. For example, I will not do any changes because I want to keep the same IP address and everything else. So I don't want to lose connectivity. So let's give it a new name. And one thing to be careful about is this here: the UID needs to be unique. And since we copied one to the other, means that this UID is the same UID of this one. This is not a good thing. This UID now is the same UID as this one. This is not a good thing. They need to be unique. So I need to generate a specific and unique UID for this guy. There's an easy way. You just do UID gen. This is going to give you a unique ID. You just copy this. Go and edit. Where is it? There. You just need to replace it. You could just make one up and hope that you are lucky enough to get a good one, but this command does that for us, and that's fine. Now, if I go back to an MCLI connection show, you'll see that well, my camera, it's actually weird. Never mind about the camera. I need to check it out. You can see that my new connection is not showing. My static 2, it's not showing here. It's not here. Not visible. Okay. But that's normal because I created a file manually without updating the NMCLI. So NMCLI connection reload, and this should be good enough to show my new one. Okay, and I can do NMCLI connection up. And I can just up to my static 2. and I will not lose connection because they have the same IP configurations. And there you go. My static 2 now it's applied to the ENS to the ENS device. My camera, it's weirdly strange. I need to check it out. No worries. Okay. Cool. Static 2 configuration. I'm just I was trying to review in my mind. So if I go to the NM TUI, you'll see that you have the connections here, the same thing, and you can use the TUI if you are feeling a little bit more tired and not brave enough to use the CLI. So this kind of wraps things up for now. For chapter 11, managed networking, we managed to see obsolete commands, new commands, how to make changes using the NM CLI and the NM TUI commands. And of course, as always, you should, and you also saw how to change by configuring the direct config files. So as always, I encourage you to experiment yourself and go. Now you know enough to explore the helps and the tabs and all of that good stuff, and explore all you want. Ask down below whatever you want to ask about this. I'm always happy to reply to your questions. Like and subscribe. That really, really helps. And I'll see you on chapter 12 or any other video on my channel. Bye for now. And let's jump right into it. So we're going to discuss the topic of this video. It's chapter 12 of the RH124, which is install and update software packages. Let's go right into it. So I have here my my first VM, whatever the case, this is the same. Now, until now, in some chapters, I have said that this can be done, and most actions commands I've shown you apply to most Linux boxes. So it doesn't really matter what or which Linux box you are using at the time. Those commands should work. For example, all the LSs, scripting, all the networking stuff that I've shown you on the previous chapter. You can use it whatever Linux you are using at the time. Those commands are just completely universal in a way. But this here, in this install and software update packages, it's very specific for Red Hat systems or Red Hat based systems. Okay, other systems will use different procedures, different mechanics, different softwares, and different ways to think about stuff. So this is very RHEL specific, or systems that use a RHEL like software packages system. Okay, so on the RH124, I would say, I'm just looking here at my notes. I say that 90% of the stuff you have learned and still will learn on the remaining chapters apply to any Linux, but software packages it's very RHEL specific. So just bear that in mind, and let's dive right into it. So in nowadays you have two tools, three in a way, that allows you to manage software packages. One is the RPM tool, the other one is DNF, and the other one is the YUM tool. So these three tools are the tools that we can and will use to manage software packages in a RHEL-based system. They are different to one another. Well, depends. We should put DNF and YUM in the same group in a way. And why? I can tell you the why right now. YUM, it's going towards the obsolete state. So the YUM, it's traveling to be obsolete. Sometime they don't specify when, maybe never. Maybe YUM will just stay on the system forever, like other examples of that. And DNF, in theory, well, not in theory, it's effective. It's going to replace YUM. However, if you know YUM, you know DNF, so they are basically the same tool. Unless you are very, very anal with this, they are basically the same tool. So if you see me using YUM, you can do the same with DNF and vice versa. So if you want to go to the comments and just talk trash about this, that's fine. That's what the comments are used for. But in a nutshell, DNF and YUM are basically the same tool. Then you have RPM, which is the older tool. By older does not mean that it's worse. It's just the kind of the legacy tool to use. It's not useless. It still has its place. It has its uses, and that's exactly what you're going to do now. We're going to start by giving RPM some use. Let's experiment a little bit with RPM. Then we can jump into DNF and to YUM. So RPM represents, if you go to the main page here, just for a second, RPM. So it means RPM package manager. So in the old days we call this Red Hat package manager. You cannot get the reasoning why, and the reason is when you look at a package that it's prepared to be installed on a RHEL system, usually it has an extension RPM. I know that in Linux, our extensions or file extensions don't mean that much, but you know it's useful. So RPM files are pre-prepared, pre-compiled files to be installed on RHEL systems. Okay, like you also have the .deb. So these are pre-prepared to be installed on Debian systems. So these are packages that are pre-prepared to be installed on its corresponding platform. You can also install package softwares using source code. It's lots of work, but with source code you can also install them on any system. Basically, source, it's kind of a universal way to install on any system, RHEL or any other. But it's a little bit more complicated than that, and we'll just stick in this chapter with the RHEL-based tools. So let's start with using RPM for some use cases. For example, I can do RPM -QA. Let's break it down a little bit more. So the -Q means query, and if I do the A, it's query all, which means that I'm going to query the RPM database of the system in order for it to show me packages that were installed using the RPM mechanics. Source code will not show here, only what's installed via RPM files. Okay, and you can see all of this stuff here that is installed on the system. If I do a quick grep here for Chrome, let's see what we get, and you have a Chrome shell, which is not the browser. Okay. So in this machine, I only have Firefox installed. I don't know why I got logged out, but doesn't matter. The only browser I have installed here is Firefox, as you can see here. But we want to obtain Chrome, and that's what we're going to do sometime in this chapter. Cool. So of course, then if I find Firefox, I should see it here installed. Perfect. Okay, so the RPM tool allows us to do RPM -QA. This is query all. This is going to show me all the packages that were installed using the RPM architecture, mechanics, whatever you want to call it. So every package I installed using the RPM stuff, it will show up here. I can do also the QI. QI means information. I can use the Firefox. Then I can get some information about a specific package. Okay, information about Firefox. I can see that the version that is installed, when was it installed, the description. So a little bit more details. I can also use for example, let's call the QD. The D here stands for documentation, and which means that the Firefox have installed a man page, which makes sense. I can do a QC. C is for configuration. So I can see that Firefox also has no config files apparently installed on the system. So that's one thing. So let me see if I have HTTPD installed here. Do I? No. Do I have it installed on my second machine? Yes. So if I do RPM -QC for the HTTPD, you can see that it installed 2 config files. Okay, and then you can actually see it. Let's search for SSH for the SSH server. We have the server here. So if we do QC, I can see that the SSH server has installed or copied some files to the file system after its installation. So this is after the installation, okay? These are packages that are actually installed. So the RPM, the Firefox is installed. SSHD server is installed. So these are, I'm checking things that are already installed. Because if I look, let me see here, I have here a file here that is not installed yet. So if I do rpm -qy and specify the file, okay, I can get the description, but I can see that it's not yet installed at least. But I can also see all of this, the QI, the QC, okay. In this case, nothing, the QD. Okay, so Chrome is not yet installed, but I can actually poke around and see stuff about Chrome. We will install it in a second. So let me see if I forget anything. Probably did. So this shows us all. This is query all. This is config files about the package. This is information about the package. This is documentation about the package. Okay. I can also do QL. QL means list. So this means that all of these files will be copied to my system after Google Chrome is installed. Okay. So lots of stuff we can do here with using RPM. Just even before installing something, I can obtain some information about it. Okay, very nice. If I decide to install, I can do RPM minus. Let's break this down. So this is install. This is verbose. This is hashtag. Hashtag means it's going to put some progress bar with hashtags. Then I'll just need to specify this. Okay, it's not a capital H but a lowercase h. And then RPM just tells me that this is nothing I am surprised. This is expected. So it's telling me that Google Chrome needs some other stuff. This other stuff, it's called dependencies, or are called dependencies. And what are dependencies, you may ask? Well, when it's very common to install a package, and that package will depend on other packages. Okay, Google Chrome is not different. It means that Google Chrome, so that Google Chrome is successfully installed, it needs to have some other stuff satisfied first. And RPM is telling me that, okay, I can install Google Chrome, but I cannot install something it needs. Now I have two options. Well, more than two, but I have some options. I can start by installing what RPM needs. So RPM telling me that Google Chrome needs some type of fonts that they are not installed yet, and RPM is not able to install them for me. Okay, so I can manually install them and go from there. Or I can force the installation. This means that Google Chrome will be installed with its dependencies not completely fulfilled. So of course I don't have to tell you that if you install Google Chrome without its dependencies completely fulfilled, things will just not work as expected. Okay, this is nothing that you don't know already for sure, but that's an option if you want to force your way through it. So RPM does not satisfy dependencies if there are any dependencies to be satisfied. RPM does not do that. In order to do that, you need to use DNF or yum, so you can actually get those dependencies satisfied for you. Okay, but we'll get there in a second. So RPM is not able to find files that are actually needed. It just throws this message and gives you the options. You can manually download this. And try again. Download Liberation Fonts, install Liberation Fonts, and try Google Chrome again. But most likely there are more dependencies that you need to satisfy. Okay, this is one of the dependencies you need to satisfy first. Probably another one will come. Another one will come. Eventually, you will satisfy all the dependencies, and Google Chrome will get installed. That's one way to do it. Another way to do it, it's using either DNF or yum. I'm going to use DNF because it's a more recent tool, but yum will just do the same job. For example, I can do DNF info. And one of the packages we have retrieved info about before. Let's use the OpenSSH server. And you get similar information, not the same information, but similar, because this basically comes from the same location, the same database, the same metadata, so it's installed. So nothing that we don't already know. But if you want to do the QC, the QD, the QL, and all of that stuff, RPM it's your tool. If you use the DNF for YUM for the info, it also works, but with a little bit less details. I'm not telling you which one is the best or which one is best. Just pick the one it works for you and be happy with that and just move forward with your life. Okay? Cool. Now let's do the installation of Google Chrome. That it's RPM package that I already have. Okay, so I went and downloaded. Okay, I went and downloaded previously the RPM package to this system. Let me just this with you guys watching, disable the auto logout. Let's go screen blank, never, so I don't get logged out. Cool. Now let's do the installation with DNF. So DNF install, and you just need to specify the full path for the file and let it do its thing. Now, as you can see, DNF did behave differently. Okay, DNF behaved quite differently because RPM just gave up and tell, oh, install this first and try again. DNF actually is telling me, okay, this is what you want to install, and these are the dependencies that are going to deal with. So I know that Google Chrome needs this, and I'm going to try and do this for you. This is good news, basically. You will get this, but I need to do this first. Are you okay with that? And Alda can say, yes, I am, or no, I'm not, of course. So if I say yes, I will say yes in a second, but if I say yes, first he will decide to get this done, and then does this. As you can see, DNF actually found the needed files, while RPM did not. This, again, is totally expected. I will show you in a second. I'm going to say no to this first, because I want to show you how DNF is finding out that these files are actually available and ready for me to install, so I can get a successfully installed Google Chrome stable in this system. So I'm going to say no for now, and I'm going to show you where DNF or YUM it's actually being able to find all of this information and how he's able to discover this is available and where is he getting this from. So this applies to DNF and to YUM, which is you go to this folder called etc yum.repos.d. As you can see, even though this is also works to DNF, YUM it's still here. So there is a very cooperation between the both. That's why I say DNF and YUM basically are the same tool for now. It's normal that DNF will just progress and get more and more developed, and YUM stays behind. That's normal. But for now, there are some files that, even though they work with DNF, they still will show YUM everywhere. So if you go here and you list, you'll have some files here that they're already here. I did not put any files here. These are all files that were added during the installation. Okay, this, even though these are Rocky servers, if they were RHEL servers, you will have some RHEL stuff here too. So, and that's fine. The only thing here that I need to be careful of, it's the following. Since I am using a Rocky system, all packages, updates, softwares, and all of that are free to get. They are just open to anyone that can get them. That's fine. However, if you are using a true RHEL system, you need to provide first, and I'll show you how it's done on chapter 14. How can we register a system with RHEL so you are entitled to receive these updates? So Rocky, it's completely open. It's fine. You just use it and abuse it. RHEL, you need to pay for support, which implies to pay for updates. So which means that in order to get updates on a real, quote-unquote, real RHEL system, to get updates on a real RHEL system, first you need to pay your fees and register your system with RHEL. There are ways to do that. I will show you on chapter 14. There is a section that I reserved for you guys just for that. And we will be able to register our system. After we register the system, then we are entitled to receive updates, and some files will get added here and edited here. Okay, but since this is a Rocky system, the files are already here, and they'll just use them. Okay, cool. Now here I have lots of files. The files are called .repo. Repo means repository, and basically a repository, it's a location where it's a place where RPMs are just stored. Okay, So repos are just web servers or FTP servers or local file system folders that you will be they're just basically organized dump, so to speak, of RPM files that can interact with DNF or YUM. I will show you in a second. So let's focus on, for example, the rocket.repo or repo, whatever. You can see here that DNF is telling me that he is able to find the files on the app stream repo. So if I go to this file, but hopefully you will see that you will be able to see app stream. So I'm looking, there we go. So I have here a repo called app stream, and that's where DNF is finding the files that Google Chrome needs. So these files can be manually edited, but they are quite simple to read. So basically you have here a section called base OS with square brackets. It's just a simple name, no spaces, just a simple name. Then you have the name section that you can just go nuts and give it a crazier name. Then you have the mirror list where it's going to list you where you can find the files. Basically there are just URLs. You can use mirror list or basically, can you see this? It's kind of bluish. It's a little bit less easier. I will remove the comments for you guys to see it better. You can use mirror list when you have a list of mirrors, or base URL if you are pointing to a specific web address. So basically these are builds to be interacted with DNF and YUM. So base URL, it's where you can find the files. Then you have GPG check. This is if you want to enable file checking authenticity. If you want to enable this repository, if you want to include it on some statistics, how often do you want to clean the cache about this file? And GPG check, it's set to 1, which means you need to point to some sort of GPG key to authenticate your packages. This is optional. This is optional. This is optional. This is optional. This should be there if you want to use this repo or not. If I put 0, he will ignore completely this repo. A name, a short name, a full name, and URL, it's mandatory, and if it's simple or not, it's also recommended. So this is not this is optional, 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 and optional, and you should be good to go. So, and all of these are just basically the same thing. So you have multiple repos for multiple reasons. It depends on the system itself. It's Rocky, rel, etc., etc., etc. And in this case, we know that the packages are coming from this repository here called app stream. So this is where he's finding the Google Chrome packages, or the Google Chrome dependencies in a way. So that's why DNF can find them and RPM does not, because RPM does not have this type of capability to search through network repositories or search through local repositories. DNF and YUM do that, so they can, when I instruct him to install something, even if I have the file or I don't. For example, we did the DNF in the network chapter. We did the DNF install and net tools. I know they are already installed probably, but let's do it anyways. Oh, they are not. Cool. So, since what does this mean? It means that the NetTools packages are not yet installed. It can be found on the base OS repository, and he will install at my command. I will say no, just to show you guys. I don't have the file here locally. Not even on the downloads directory. I don't have it. I don't have the file here on my current folder, but if I do an install, he will actually find these files and offer to install them for me. Why? Well, you know the answer. It's going to scavenge through the repositories that are configured and enabled. He's going to try to find the tool, and he will find that tool. Okay, and offer me to install. So the first time you interact to the repo, he's going to build the local cache. Let me clean it. DNF clean all. So let's say this is going to clean my local cache. So now the next time I run this, which is now, it's going to act like it was the first time. So basically it's going to contact all the configured and available repos on those repo files. It's going to download to itself a local cache, a small local cache. So the next time I'm going to say no. If I do this again, you'll see that he will not scavenge the repos because he already has a local cache. And this local cache should be cleaned every once in a while. So you should clean your local cache every once in a while. So you will force the DNF or YUM tools to fetch the metadata about the repositories. Okay? Because if you update a repository, if your repository, for example, gets 1,000 new files, DNF will not find it because it's using its own local cache. So local cache says the repo has 100 files, the repo has 2,000 files. He will not find those extra files because he's using his local cache that is outdated. So you can clean it manually, you can clean it automatically. Just make sure you clean your local cache every once in a while. So if I'm not going to say yes because I don't want to, but if I say yes, he will just install this and that will be the end of it. So let's go back to Google Chrome, finally. And now you understand better what he's doing. So he's telling me that I will install Google Chrome for you. That's fine. But I will also need to update or install these packages here. They are going to come from the app stream repo, which is fine. Okay. If I say yes, he's going to upgrade all of this, install some other bunch of fonts, and finally install Google Chrome. I will show this you guys real time. Okay. I have GPG enabled, so I have to install the keys, and I'll accept that. The keys are installed only once, so you don't have to say this every single time. And let it just do its thing. And first install the fonts, which are really small. They are just a few kilobytes big or 1 megabyte tops. And he installed Google Chrome, which means that if I go here, I probably will see Google Chrome available for me to run. There you go. So I can run Google Chrome, no problem. Okay. So I didn't have Google Chrome before. Now I have it. And you guys can see this is the first time I'm actually running it. This is if you have installed Google Chrome on Windows, you know this is the first. This also always shows up in the first time you run it, and there you go. You just hear all good and dandy. Google Chrome is installed successfully. Let's go back to the NetTools. As you can see, it's going to ask me yes or no. If I want to, I can add an option here, which is the -y. Sorry, this is going to say yes to any question. And there are no interruptions and just goes through and all the questions he may have to ask, all the yes or no questions are answered yes, and that makes things more seamless. And that's kind of it for install software and update software packages. Watch and rewatch this every time you want to know more about this. Don't forget that if this was a real RHEL system, you had to register that register your registration. Well, that sounded stupid, but prove to RHEL that you have this system registered and activated so you can get the updates from RHEL. You can install stuff from any other source on any RHEL system. You don't have to have your system registered or true RHEL system registered in order to install RPM packages. You can install your RPM packages, any RPM packages from any source. No problem. But there can be some problems because if you open a support case with RHEL, obviously with your support contract paid for, of course, but if you open a support case and the Red Hat engineer will notices that you are running a system with a non-truly updated and non-truly supplied RHEL packages, you may run into some, political issues. But technically it is possible. But if you want to install official packages and official patches from RHEL, you need to pay your fee and prove that you have your paid and paid for. That's it for chapter 12. Stay tuned for chapter 13, which is going to be Access Linux file systems. Like and subscribe, it helps, and I'll see you in the next one. Cheers, guys. Okay, so let's then jump like we usually do. Let me just clear a couple of things directly into our console. Okay, so the theme is Access Linux file systems. So in this chapter, we're going just to see if when we reach the RH124 chapters, we will also do. Okay, so this is just a matter of seeing our file systems. By seeing, I mean how many hard drives you have, how many SSDs we have, do we have any NVMEs, etc., etc., etc. And identify them and access them. As a bonus, I'm also going to show you how to access a USB thumb drive, just as a teaser for things to come. And we're going to wrap things up with how can you use the find command and the locate command, okay, to find files. I think we have covered this before, but we just covered it again just to make sure. So if you want to identify your storage devices, you have many options. We're going to explore the text file called cat-proc partitions. Partitions. Then we're going to explore the ls-blk, blk ID, and the du command. Du, it's fine. Okay, so let's start by this one, and I'm going to check the contents of a text file. So, and this you have what you have currently in our machine. So here in the server, you have an NVMe drive. And this NVMe drive has this amount of space available. So what I'm going to say to you guys right now, it's not scientifically very correct. And if you are very picky and anal about this stuff, you will just disagree with me, and that's fine. I'm okay with that. But here you have here a way to find the size. So here I have the blocks information. Okay, means that this is around 20 gigabytes of almost 21 gigabytes of space. So 1, 2, 3. Okay, 1, 2, 3. This means 20 gigabytes of space is what you have here available on this storage device. In this case, in an NVMe SSD, and I have P1, I have P2. This is partition 1. This is partition 2. I am not going to discuss partitions at this point. It's going to be discussed on the RH124 video series. Like and subscribe to get notified. This means SR0, it's our optical device, DVD, CD. Again, this is a virtual machine, so it's virtualized in some sort of optical drive. And DM0 and DM1, it's regarding LVMs. We will discuss LVMs on the RH124 video series. Like and subscribe to get notified about that too. So we have one storage device, one main storage device. It's an NVMe device. It has 20 gigabytes of space with two partitions. One partition it's 1, 2, 3. It's about 1 gigabyte big, and this one is a reminder of the space, and that's fine. Cool. Let's do the ls-blk. Why? Because these storage devices in Linux are called block devices. Block devices are storage devices. And ls, it's to list. I think you guys can relate to that. So like I said here, this is our optical drive, and there we go. This is our optical drive. Okay. This is our first hard drive, and I said it had around about 20 gigabytes, and I was not far off. I said this one was 1 gigabyte, and I was correct, and this one 19 gigabytes, and I was correct. So you can see on this command the information, or you can see on this one. Just take your pick, and you can actually use one or the other. This is my boot partition. This is a partition, and this is our root drive. This is our swap partition. I'm going to talk about these special ones that are LVMs on RH124. So like and subscribe to get notified and learn all about that. Cool. Now, blk ID. Well, you get the idea. It's a little bit more of the same, right? So here you can see the UIDs of each partition. So like we discussed on the network, many devices have universal IDs that identify the device. Network connections was one of them, and these are partitions and then these drives. Okay. You can also see that on the ls-blk. You can do -fs, and you can get all the juicy details with ls-blk. You can use other ls-blk, blk ID, cat-proc partitions, whatever the case may be. you are okay with that, and that's fine. There is no one that is better than the other. There is no best command to use. Just use the one that you are more comfortable with. It's all fine and cool. Now let's access a thumb drive. Okay, so if I a thumb drive or any other drive, thumb drive, external USB, external hard drive, whatever the case. Here, let's look at the before. This is what you have before. Okay. Now I'm going to insert. Give me a second. I need to access my console. I'm going to insert my thumb drive. And if I go here, you see I have something new here. This is my thumb drive. So something changed. So before I didn't have the thumb drive. Now I have the thumb drive. Let me disconnect it again. Let's quick seconds. Now if I disconnect it, it's gone. Okay. Another way to get this under control is to a command called dmasg. This command will allow us to see kernel messages, not all but some, and the ones you can see here are going to show USB devices getting connected. So let me connect it again one more time for the last time and keep it connected. Connect. If I go here, as you can see, a USB device was connected and was addressed. Cool. Now if I go to my proc partitions, it's there. LSBLK, it's also there. And as you can see, it was automatically mounted. Okay. What is a mount? A mount is when I make a relationship between the folder and the storage device. In this case, since on this machine I already have the graphical interface installed, I have GNOME installed and all of that good stuff installed, it will detect the drive and auto-mount it like in a Windows machine. So it means that I can see the contents just by listing the contents of the folder. So this is the mount. It's a relationship between the device and a folder. This is because this machine here has already installed GNOME and all the graphical interface stuff. Since it's the case, GNOME is auto-mounting. My graphical interface is auto-mounting the device. But if you remember, this guy here does not have anything installed regarding graphical interfaces. This guy here does not have. Which means, let's be okay. I'm going to disconnect the USB thumb drive from the first machine. And I'm going to connect to this second machine. Okay. So if I go here, it's disconnected. And if I run the command here, it shows as connected. See? Let me clear this one. Now the thumb drive is connected to the second one. But if I go here, it's not auto-mounted. So if you remember correctly here on the first one, he would just auto-mount. Oh my God, where is it? Did I lose that information? I probably did. Hopefully not. Blah 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 blah. There it is. I didn't. So he auto-mounted my thumb drive to this folder, run media. That's actually X Windows doing that for me, or GNOME. Here, that did not happen. The device is there, but is not auto-mounted because the second machine does not have the graphical interface installed. So in order to do this manually, first you need to be root, then you create a folder. Anywhere will be okay. I like to use the MNT folder because MNT folder already exists, and it's just MNT corresponds to mount. So let's just make use of it. Then I can do just mount. I will specify the device. If you don't remember, just go back here and it will tell you. And it's called SDA1. Then I will tell them to mount on the currently created folder. Now it means that my physical device SDA1, it's my thumb drive, it's there, okay? It's mounted to this folder here, which means if I list this folder, I see the contents. If I go to the LSBLK, I see it mounted. Okay? So it's as simple as doing mount as root. You need to be root to do that. As root, you mount the device to the folder. Any folder will suffice, and there it is. Now, the question is, will this survive the reboot? No. I will not do this. I will not make this permanently. I will not make this survive reboots because I'm going to discuss this on the RH124. Like and subscribe to get notified about that. But you can make this happen automatically on each reboot. In this case, it will not occur, but if you want it, you could. Okay? So at this point, you know how to identify your storage devices, proc partitions, LSBLK, BLK ID, and can also do the disk usage. Okay? Or disk free. Disk free also allows us to see your devices and where they are mounted and their spaces. I do like the LSBLK. I prefer this one, but this one is also good enough. Some people prefer it. It's fine. You can actually see them mounted here. Okay? And I like to put the -8 because it shows us as human readable, which will give us gigabytes and megabytes instead of weird log units. Okay? So if I reboot the server, I will not because that's unneeded. But if I was to reboot this server, this mount will disappear. This is not prevail. This mount will not prevail. Okay? If you want this mount to prevail or persist, you need to edit a file. Okay? And that file is going to be read on the boot process, and it's going to apply all the changes that that file identifies and lists that could include the mount of this pen drive. Okay? To wrap things up about chapter 13, let's discuss about the locate command and the find command. Locate and find allows us to, pardon the redundancy, the locate and the find allows us to find files and folders on our devices. If I do locate, for example, the fstab file, okay, my Rocky 2 does not have locate installed. Just to save some time, let's go to Rocky 1. And the locate file, the locate utility, it's a very simple utility. It does not offer anything fancy. It will just locate a file based on our pattern. That's it. Also, the locate will just use a pre-indexation of our hard drive or storage device, which means that all of this was indexed at it's kind of a cache he builds. If you want to update the cache, just to update DB, he will update the cache and then he will locate. Let me give you an example of the importance of updating the cache. Let me create a file called in etc called like potatoes.pot. Hi. If I do a locate for the file I just created, it is not found, but if I update my cache, then he is found. Okay, so it's important to update your locate cache if you had any major file system updates, or else the locate will not find the changes. This update occurs every day automatically around midnight, but if you want to force the update to occur now, you can just do update DB and you should be good to go. The one is the find. The find, it's a very powerful tool, very powerful tool, too powerful for me to explain in this chapter. Okay, but you can use find, for example, with many patterns. You can find for file name, file size, permissions, change date, many options. Let's do the simplest of them all, which is let's find on the etc folder a file named the potatoes.pot that I just created. And there it is. So the find does not use a pre-cache, which means that it might create a little bit more IOPS on your hard drive, on other storage devices, but it has many more options. It's much more powerful than the locate. So if you want to do a quick locate, you just use a locate with the corresponding update. If you want to do some more in-depth and in-detail find actions, you can just use the find, and you should be good to go. Can use for file name, file sizes, change dates, owners, permissions, specific permissions, and all of that. The find allows you to do all of that powerful finds so you can find your file. That's it for chapter 13. Next one will be chapter 14, which is also the last chapter. Any questions, put them down below. Like and subscribe, it will help the channel to grow. And I'll see you in the next one. Without further ado, let's jump into the console, shall we? So, we're going to discuss two main things today. It's going to be how to install and run Cockpit. If you don't know what Cockpit is, you'll find out soon enough. And how can we get some information about our servers so you can make it a little bit easier to get some support, either from official Red Hat engineers or from the community. Okay, so let's just discuss what Cockpit is. Well, Cockpit, it's not something new. Cockpit, it's been around for some time now, but it kind of gained mainstream attention recently. And Cockpit, it's a web browser-based administration tool. So it means that I can open a web browser, connect to my server, and get some tools so I can admin the server without the need of touching the actual console. So in theory, let me just pull a couple of things here. So in theory, this is not working yet, which is trying to connect to the IP address of my server. Let me just confirm that, just to make sure that I'm actually connecting to the correct IP address. It's the 114. Oh, it's 250. Okay, 250. Still not working. It's expected. So that's the fconfig. I have been messing around with the networking, so I was connected to the wrong IP address. But at this point, if you went through the networking chapter, you know what I'm doing here. So yeah, it's in theory at least, it's a 250 IP address I need to connect. Let me just double check that. So an MCLI connection show. In theory, I'm using the static 2. And I can double check my IP. And well, I have two IP addresses because one is automatic and the other one is because I have my connection set to auto. I can fix that in a second. See auto. So it means I'm going to obtain my IP address from the HTTP and also my static IP address. So in theory, both IPs would work. But let me copy this. Let me do something like an MCLI connection modify static 2 and method. It's going to be manual. Okay, and I'm going to do that also to the static, which means if I go to the show, I should be methods manual. Fine. So I don't have two IP addresses now. I just have the main one, which is nice. And it's 250 and it still does not work 9090 because I don't have Cockpit enabled in the server yet. So let's try to enable Cockpit here on Rocky 1. Where's my console? There it is. Now let's pull the console here. Let's try to organize our space. And let's put this on top. So this is looking nice. Okay, let's see if I can remember this from memory. Let's try to install it first. So DNF install Cockpit, or sorry, make sure that it's already installed. And it's not yet installed. So it's installed. Let me just do a quick check for you guys. Let me just disconnect from my terminal, reconnect. And hopefully we will see a message. No, we don't. Okay, it's not showing the message I wanted to see. Because sometimes it shows how to enable Cockpit, but it's fine. We don't need that anyways. I'm going to show you. Let's go put this on top again. Okay, let's go get some root access here going. Of course, I messed up the password like I usually do. And now, let's just refresh here. It should not work yet, okay? Because it's not enabled. So let's see. That's then enable it. So let's do systemctl enable minus now cockpit should be good enough. Cool. Now in theory, it should be good to go. See, let's just double check. In theory, let's see if the firewall it's cooperating with us. So this is going to be unsafe, but we do know, and there we go. Now I can just type in my username. And there we go. Cockpit is working. Since, as you know, we have been going through with me with the SSH setup process, and in that route cannot log in remotely, but I can just click here, type in the password for the student. Student has sudo access, and now this cockpit has full privilege over the system. And I can watch my logs, I can check my storage, configure networking, set up containers, set up accounts, set up services, and all of that you can see here on the left hand side. So you can see all of this stuff you can do. And this is pluggable, which means that you can add stuff here if it's not available here. And it's also the cockpit, it's also the preferred method, so to speak, of it's not the case here, but it could be, to actually admin virtual machines. So beforehand we had the version and those tools, but now we have you can install the plugin for the virtual machines, and you can explore cockpit. I could click here, I could click everywhere and show you, but it's much better that you actually experiment yourself and click around and see what can you do. So this is a good alternative to interact with the server if you don't want to use the terminal interface to interact. I do prefer the terminal, but sometimes I come here, it can be useful, especially some specific firewall rules and all of that stuff. Speaking of firewall, let's go here. Let's just get this out of the way. That's not what I wanted to do. I wanted to do this and do this and do this. Okay. So as you can see, firewall, it's enabled. Okay. And you have also here the possibility of configure the network. I can go to the firewall rules, and by installing cockpit by hand, the 1990 port was already authorized through the DNF installed. That's why it's already authorized and ready to go, or else you had to open the 1990 port or change cockpits to some other port if you actually prefer that. So that's cockpit for you. So this is just a matter of installing, enabling it, and you should be perfectly good to go. Oh, this is Rocky 2. I wanted to show you Rocky 1. And there you go. You just need to install cockpit and then enable it, and you should be ready to go. You just type in your hostname or IP address, port 1990, and you should be perfectly good to go here. You type in your non-root user, then you sudo to the root user if you have to, and there you go. If you want to receive some extra support, well, it's normal when you ask someone for help to get support about a problem. It's normal for those people or person to ask you more files of the server or more information about the server that you are about to request an assistance for. So that person could just request you file by file and send me log A, send me log B, send me log C, and you had to find all those logs by yourself, by hand, or you can just use a tool called SOS Report. And this is a very pluggable tool, which means you can extend its capabilities at your liking. But by default, you just hit SOS Report as the root user, okay? And just follow along what he says. So just continue. Enter the support case. The support case number is what you get when you open a support case. For example, an official support case with RHEL. and they're going to give you a number of your support case. You can put here the number, and it's going to generate a summary of your system, and like the main log files, IP addresses, output of the system sockets and system units, kernel messages, storage devices, networking IP addresses and devices, network devices, well, all of boot process, boot config files. Well, it's going to make a summary of your system that will make it easier for you to send to the person who's assisting you getting your problem solved. Instead of sending file by file, one by one, it just creates a tarball that you can just send it to the whatever person is helping you out. So if I go here, the file is created with its checksum. Okay, I can just send this to the person with the checksum, or I can just extract it and see its contents myself, which is fine. It's just a bunch of output redirected files that you can then just have a quick summary. Of course, you can use this for your own benefit. You can have a small database on a shared folder of system summaries of all your services, of your servers, sorry. And this can do this for you, so you don't have to do this by hand and to collect file by file. That could be very, very tiresome. That concludes our chapter 14, Analyze Servers and Get Support. Let me know in the comments below if you have any questions. I am happy to reply. Like and subscribe, it really helps, and I'll see you in the next one. Cheers, guys. Well, that concludes our RH124, all 14 chapters. Let me know in the comments below of this video or any of the other videos I just uploaded for this video series. Get ready for RH134. Get ready for your EX200 exam. But beforehand, wait for my series about the RH134. Let me know in the comments below if you have any questions, doubts, anything you want to tell me, or just say hi. Like and subscribe, it helps, and I'll see you in the next one.